Yesterday, at precisely 11:47 Coordinated Universal Time, an event of profound significance unfolded. Or, perhaps more accurately, an event of equal significance failed to materialize. For months, the global populace had been captivated as the celestial body designated 3I Atlas embarked on its journey towards an unprecedented close proximity to our Sun. This cosmic traveler carried with it the weight of countless speculative theories, the fervent hopes of extraterrestrial life enthusiasts, and the reasoned skepticism of the established scientific community. The appointed moment arrived. The interstellar visitor completed its gravitational dance around our star, traversing at a velocity of 68 kilometers per second. It was enveloped by 770 watts of solar irradiance per square meter, yet remained concealed from terrestrial observation due to the Sun's overwhelming radiance. And then, a profound stillness. There were no observed adjustments to its trajectory, no deployment of diminutive probes, no evidence of energy acquisition, and crucially, no grand reveal of an alien mothership during what many anticipated as humanity's pivotal first contact. It behaved precisely as any celestial body of its nature would, adhering to the immutable laws of gravity and momentum as it navigated the vast emptiness of space. Yet, it is this very predictability that renders October 29, 2025, a date etched in astronomical history for its extraordinary lack of sensationalism. The silence itself has become a deafening proclamation. When an outcome deviates entirely from forecasts, when an object's behavior aligns perfectly with the dictates of physics, and when every speculative notion dissolves under the stark illumination of empirical evidence, we are compelled to confront a more disquieting inquiry. Why did so many individuals, including esteemed scientists, anticipate a divergence from the expected? What did we perceive in 3I Atlas that ignited the possibility, however faint, that this instance might mark our realization of not being alone? If this exploration of yesterday's cosmic anticlimax resonates with you as profoundly as it does with me, kindly consider expressing your appreciation through a like and subscribing to sustain this ongoing endeavor. The absence of any extraordinary occurrence at perihelion is, in itself, remarkably significant. Let us commence by examining the factual data from yesterday, October 29, 2025. At precisely 11:47 Coordinated Universal Time, 3I Atlas reached its perihelion, its closest point to the Sun, situated at 1.356 astronomical units, approximately 203 million kilometers distant from our star. The object maintained a velocity of 68.3 kilometers per second, proceeding along its hyperbolic trajectory with an eccentricity measurement of approximately 6.1. Every telescopic instrument capable of tracking it through the solar glare, every spacecraft strategically positioned to capture a fleeting glimpse, every amateur astronomer equipped with the requisite apparatus trained on the constellation Virgo, all registered the same phenomenon: a comet exhibiting characteristic outgassing, adhering to Newtonian principles, and behaving in exact accordance with the predictive models generated by the Jet Propulsion Laboratory's trajectory analysis. The margin of error for the timing was mere minutes. We possessed a precise understanding of when it would occur and where it would be. For an object that, over several months, had been subjected to a multitude of designations, ranging from extraterrestrial mothership and Trojan horse to a reconnaissance probe with potentially adversarial intentions, its passage through perihelion was remarkably anticlimactic. There was no observed lateral acceleration, no controlled expulsion of energy, no deviation in its path. Its velocity remained steadfast at 68.3 kilometers per second, neither accelerating nor altering its course by even a fraction of a degree. The hyperbolic orbit remained a testament to the unwavering force of physics. However, let us pause and contemplate this development, for the very absence of an anticipated event constitutes an event worthy of meticulous examination. Over the preceding 4 months, since its discovery on July 1st by the Asteroid Terrestrial Impact Last Alert System, this celestial body has occupied a singular position within our collective consciousness. It transformed into a canvas upon which we projected our most fundamental inquiries regarding our place within the grand tapestry of the universe. Are we solitary entities? Would we recognize advanced extraterrestrial technology if it were presented to us? Could a civilization possessing superior technological capabilities successfully mask a spacecraft as a naturally occurring object? These are not trivial questions. They are precisely the questions that define humanity's profound relationship with the cosmos. And yesterday, as the clock struck 11:47 Coordinated Universal Time, these questions did not receive answers. Instead, they were postponed. For here lies the essence of what makes 3I Atlas's uneventful perihelion passage yesterday so simultaneously gratifying and frustrating. This was intended to be the ultimate validation. This is how it was characterized by Avi Loeb. The perihelion passage was meant to be the decisive moment. If 3I Atlas were of artificial origin, if it were a mothership, if it possessed any form of propulsion control, perihelion would be the opportune moment for it to act. The underlying physics are undeniable. When an object reaches its maximum velocity, when it is at its closest proximity to the sun's gravitational pull, that is the precise juncture when any course correction is most energetically efficient. This principle is known as the Oberth effect. By expending fuel when orbital velocity is at its apex, one achieves the greatest alteration in kinetic energy for the minimal expenditure of propellant. Therefore, if 3I Atlas were poised to undertake any action, any maneuver that would definitively establish it as more than merely a fragment of ice and rock originating from another star system, yesterday was the designated day. And it performed no such action. Absolutely nothing that was not already predicted by the established tenets of cometary physics and celestial mechanics. Its trajectory remained consistent. No anomalous accelerations were detected. No sudden increases in luminosity occurred that could not be attributed to enhanced outgassing induced by solar heating. No radio transmissions were intercepted. No secondary objects were ejected from the primary body. Nothing out of the ordinary transpired. One might be inclined to assume this marks the conclusion of the narrative. An object behaves naturally. The case is closed, and everyone can return to their routines. However, this is not precisely what transpired, because even as the observational data was being compiled, even as astronomical observatories confirmed that 3I Atlas was meticulously adhering to its predicted trajectory with almost monotonous precision, a peculiar shift was occurring within the discourse surrounding the object. The silence observed at perihelion did not extinguish the conversation. In certain respects, it amplified it. Within hours, platforms like Twitter, or X as it is now designated, were inundated with reactions. Some expressed satisfaction, championing the validation of mainstream astronomical predictions. "See," they proclaimed, "it's just a comet. No cause for alarm. The scientists were correct all along." Conversely, others intensified their adherence to conspiracy theories. Naturally, nothing significant occurred, they argued. They are deliberately concealing the genuine data. Do you truly believe they would disclose such information if something had indeed transpired? This is precisely the scenario a cover-up would entail. And then, a third segment of the population emerged, perhaps the most intriguing. Individuals who experienced a peculiar sense of disappointment. This was not born from a genuine conviction in the existence of alien motherships, but rather from the fleeting possibility that, for a brief interlude, the universe had felt infinitesimally less solitary. The prospect, however remote, that humanity might stand on the precipice of confirming the existence of intelligent life beyond Earth had been intoxicating, and yesterday, that possibility seemingly evaporated. A user on Reddit articulated this sentiment with remarkable clarity in a post that garnered thousands of upvotes within a matter of hours. They wrote, "We are now nearly 2 hours past the perihelion of 3I Atlas, and to the surprise of no serious observer following this event, nothing has happened. There has been no maneuvering towards Earth. It continues to follow its expected trajectory. Its velocity has not exceeded 68.3 kilometers per second. The tone of this message was one of almost weary resignation. Naturally, nothing happened. What did you anticipate? Yet, beneath this surface of weariness, one could detect an underlying current, a subtle hint of disappointment that the universe had not presented us with an unexpected revelation. And this, from a sociological standpoint, is what renders yesterday's event so compelling. Setting aside the astronomical implications for a moment, we inhabit an era where speculative theories propagate with the speed of light, where deepfake technology can fabricate statements attributed to scientists, and where the demarcation between conjecture and misinformation becomes increasingly blurred with each passing day. 3I Atlas coalesced into a perfect storm for such phenomena. An interstellar object possessing demonstrably unusual characteristics, a prominent scientist willing to publicly engage with the hypothesis of extraterrestrial intelligence, a perihelion passage that coincided with the object's obscuration by the sun from Earth's vantage point, and a populace already conditioned by decades of science fiction to anticipate that first contact might originate from an unforeseen direction. The conditions were unequivocally ripe for mythology to take root, and indeed, it did. Videos accumulating millions of views declared 3I Atlas to be confirmed alien technology. Fabricated clips, purported to feature physicists such as Brian Cox and Michio Kaku, presented statements that they had never actually uttered. Reddit forums engaged in exhaustive dissections of every available piece of data, meticulously searching for concealed patterns. TikTok became a vibrant hub for theories concerning government cover-ups and impending revelations. The ratio of genuine information to unsubstantiated claims became almost insurmountable. However, here is the crucial point. Beneath all this apparent chaos, a genuine scientific narrative was unfolding. 3I Atlas is a tangible object with observable peculiarities. The scientific discourse concerning its properties, its composition, its origins. This debate is legitimate and ongoing. The events at perihelion did not resolve every enigma. They merely served to discount the most extraordinary explanations. And in the realm of scientific inquiry, this is precisely how progress is achieved. One systematically eliminates the improbable, and whatever remains, however unlikely, warrants more rigorous examination. Therefore, let us now focus on what was empirically observed yesterday. Abstracting away the hype, the speculative theories, and the pervading sense of disappointment, we find that multiple observation platforms successfully tracked 3I Atlas through its perihelion passage. Despite the inherent challenges presented by the celestial geometry, instruments such as the Noah's Ark, 19 satellites CC-1 coronagraph quartet, and the polarimeter designed to unify coronal and heliospheric observations, maintained vigilant watch. The Solar and Heliospheric Observatory, SOHO, meticulously documented its passage through its LASCO C2 and C3 coronagraphs. These are not rudimentary operations. They represent sophisticated professional instruments meticulously engineered for the observation of the sun and its immediate environs. And each of them consistently corroborated the same finding. At perihelion, 3I Atlas presented itself as a comet experiencing significant thermal stress. Its luminosity increased, though not dramatically, transitioning from an approximate magnitude of 15 to a magnitude of 11.5. This alteration is entirely consistent with an elevated rate of outgassing as the solar heat vaporized an increased quantity of its icy surface. The coma, the ethereal halo of gas and dust that envelops the nucleus, expanded precisely as anticipated. The tail structures evolved in a manner that aligned with computational models, simulating the behavior of dust and ion tails under intense solar radiation. Every measurement, every observation, every data point unequivocally corresponded with the expected characteristics of a natural cometary body undergoing the rigors of perihelion. And yet, consider the implications of this reality. We have just witnessed an object originating from another star system. an object that formed billions of years ago within a molecular cloud surrounding a sun whose identity remains unknown to us, traversed the most intense phase of its journey through our solar system. This object is now on its outward trajectory, accelerating as the sun's gravitational influence wanes, heading back into the profound darkness that lies between the stars. In a few short years, 3I Atlas will have receded beyond the orbital path of Pluto. In a few decades, it will be more distant from the Sun than the Voyager probes. In a few centuries, it will once again be a truly interstellar entity, utterly beyond the reach of any technology currently within our possession. This moment, this perihelion passage on October 29, 2025, represented humanity's most opportune chance for close-up study. We had spacecraft strategically positioned. We had ground-based telescopes prepared. We had amateur astronomers across the globe contributing their valuable observations. We deployed every resource at our disposal to study this object, and in doing so, we gained an immense amount of knowledge. However, we also confirmed that the universe does not always provide straightforward answers. Occasionally, a comet is simply a comet, even if it originates from beyond our solar system. Nevertheless, the question that persists, the question that imbues yesterday's silence with such profound weight, is this: why were we so readily inclined to believe it might be something more? What specific attributes of 3I Atlas compelled even the most skeptical minds to pause and contemplate the possibility of something extraordinary? This is not an inquiry rooted in astronomy. It is a question about us, about our inherent hope, our pervasive sense of loneliness, and the deep-seated human yearning to ascertain that we are not the sole sentient beings gazing upwards at the celestial expanse, pondering these very questions. And this fundamental question propels us directly into the next unfolding mystery. For while nothing overtly dramatic occurred at perihelion, while 3I Atlas behaved precisely as a natural celestial body would be expected to, the overarching narrative concerning its nature, its point of origin, and what it may ultimately reveal about the universe beyond our solar system, is far from concluded. In many respects, it is only just commencing. The truly significant observations are poised to begin. The spacecraft designated to conduct close-up examinations in the coming months are already in their optimal positions, and the data we will acquire as 3I Atlas continues its transit through the outer reaches of our solar system may provide answers to questions we have not yet even conceived. But first, it is imperative that we address the conspicuous, unacknowledged element in this discourse, the hypothesis that stubbornly refused to dissipate, even in the face of yesterday's uneventful passage. The notion that 3I Atlas might not merely be traversing our solar system by chance, but rather that its presence here is deliberate, serving a specific purpose. And this purpose might entail something far more unsettling than a simple first encounter. What if the true narrative is not defined by what transpired yesterday at perihelion, but by what may be occurring at this very moment as 3I Atlas continues its trajectory towards its next significant celestial rendezvous? What if the silence observed at perihelion was not the culmination of a test, but merely the initial phase? What if an event is unfolding that we currently lack the instrumentation to detect? Consider the theory of energy absorption. Did it draw power from the sun? The sheer magnitude of the numbers becomes staggering when subjected to rigorous calculation. At perihelion, 3I Atlas was receiving 770 watts of solar energy per square meter of its surface. Now, if we consider the conservatively estimated minimum diameter of 5 kilometers, this translates to a surface area of approximately 78.5 million square meters. Performing the arithmetic, we arrive at a figure exceeding 60 gigawatts of power impacting this object. Not 33 gigawatts as initially suggested by some estimates, but a truly astronomical quantity of energy. To provide context, this is approximately 45 times the energy output of a large-scale nuclear power plant. All of this immense power concentrated upon a single object for the duration surrounding its perihelion passage. Consequently, the question that arose in the aftermath of yesterday's transit is as follows. What became of all that energy within a conventional comet? The answer is remarkably straightforward. The energy serves to heat the surface, instigating the sublimation of ices, transitioning directly from solid to gaseous states. This outgassing process is responsible for the formation of the coma and tail that we observe. A portion of the energy is reflected back into space. Some is radiated as infrared energy. The entire system then reaches a state of equilibrium between the incident solar radiation and the comet's thermal response to that heating. It is a process that, while perhaps appearing chaotic, is ultimately predictable within defined parameters. However, in the days leading up to perihelion, an alternative theory began to gain traction. What if 3I Atlas was not merely passively absorbing this energy? What if it was actively harvesting it? At first glance, this concept may sound like pure science fiction, but let us examine it with earnest consideration. If an advanced civilization were to dispatch a probe on an interstellar voyage, one of their paramount engineering challenges would undoubtedly be power acquisition. Solar panels function exceptionally well in proximity to a star, but in the vast, dark expanse between stars, reliance would be placed upon nuclear power sources or some exotic technology yet to be conceived. But if the probe's trajectory were destined to bring it in close proximity to a star, why not design the spacecraft to capitalize on this opportunity? The concept of stellar energy harvesting is not novel within theoretical scientific circles. We have conceptualized numerous possibilities, ranging from solar sails that harness photon pressure for propulsion to hypothetical constructs such as Dyson spheres, capable of capturing a star's entire energy output. A spacecraft engineered to absorb energy during a close solar pass would represent a considerably more modest undertaking. However, the underlying principle remains identical: converting stellar radiation into usable power, storing it, and subsequently utilizing it for whatever mission objectives are required, be it propulsion, communication, operation of onboard systems, or even manufacturing and repair processes. This is where the name Michio Kaku began to appear prominently in viral social media discussions. Clips, allegedly featuring the esteemed physicist, purported to show him asserting that 3I Atlas would acquire additional energy during its flyby, and that this energy augmentation could serve as confirmation of extraterrestrial intelligent life. The critical issue, however, is that the majority of these clips were either drastically taken out of context or were outright fabrications. Kaku himself never articulated these specific claims regarding 3I Atlas. The viral screenshot that appeared to show him speaking on a news program about the object was, in fact, extracted from an interview conducted in February of 2025, months before 3I Atlas was even discovered. The accompanying quotes were artificially generated, pieced together from disparate sources, and presented to create the illusion of breaking news when, in reality, they bore no such resemblance. Nevertheless, the damage was already being done. The energy absorption theory began to acquire a life of its own. Reddit forums meticulously analyzed every pixel of available imagery, meticulously scrutinizing for any indication that 3I Atlas was exhibiting a luminosity exceeding expected levels, or that its spectral signature displayed anomalies consistent with artificial energy collection rather than natural outgassing. YouTube channels boasting millions of subscribers presented intricate diagrams illustrating how an alien mothership might disguise solar panels as a cometary coma, covertly collecting power while simultaneously appearing to shed ice and dust. The theory acquired just enough scientific plausibility to resonate with non-expert audiences. After all, we are aware that 3I Atlas possesses an unusual composition. The detected emissions of nickel, unaccompanied by corresponding iron readings when the object was still distant from the Sun, do not align with conventional models of cometary behavior. If its composition is already anomalous, why should its energy profile be exempt from such peculiarity? And herein lies the crux of the matter. When one commences with genuine scientific enigmas and then superimposes layers of speculation, distinguishing between credible information and unsubstantiated conjecture becomes an exceedingly formidable task. So, What precisely transpired with the energy that impinged upon 3I Atlas at perihelion? The observational data gathered yesterday provides a remarkably clear answer, and it is not the one favored by proponents of conspiracy theories. The comet did indeed brighten, but not in a manner that suggests energy absorption for subsequent storage. Its increased luminosity was a consequence of a greater volume of surface material undergoing vaporization. The coma expanded. The tail became more pronounced. The spectroscopic analyses, conducted by instruments capable of observing it through the solar glare, revealed precisely what would be expected from a comet subjected to intense thermal stress. Water vapor, carbon dioxide, carbon monoxide, all the volatile compounds that would naturally sublimate from an icy celestial body were detected. No anomalous spectral lines indicative of artificial processes were observed. No unexpected radio emissions, which might suggest the activation of power systems, were intercepted. No sudden shifts in reflectivity occurred that could be construed as the deployment of solar panels or the activation of energy-collecting surfaces. The object absorbed energy in the same manner that any dark, rocky, or icy body would. It heated up. A portion of this absorbed heat facilitated outgassing. Another portion was radiated back into space. The remainder was conducted into the object's interior, slowly warming the deeper layers, which will continue to outgas for weeks or months as 3I Atlas continues its outward journey away from the Sun. However, what renders this entire discussion regarding energy absorption scientifically intriguing is this. Even though the theory is almost certainly unfounded, and even though yesterday's observations offer no discernible evidence of artificial energy collection, the question itself illuminates something significant about our perception of interstellar objects. We are coming to realize that our ingrained notions of what constitutes natural versus artificial may not be as reliable as we previously assumed. Consider this scenario. When Voyager 1 and Voyager 2 were launched in the 1970s, they were equipped with power sources known as radioisotope thermoelectric generators, or RTGs. These devices ingeniously convert the heat generated by radioactive decay into electrical energy. They operate passively, with no moving parts and no combustion, relying solely on heat and thermocouples. If an alien civilization were to discover one of the Voyager probes drifting through interstellar space and lacked the context to understand its purpose, would they recognize it as an artificial construct? Or would they perceive it as an anomalous rock that coincidentally emits a faint thermal signature? The fundamental point is that we do not definitively know what advanced technology would appear like if it were meticulously optimized for interstellar travel. We tend to envision gleaming metallic surfaces, unambiguous markers of artificiality. However, an engineer tasked with designing for a journey that might span millions of years would undoubtedly prioritize durability over aesthetic considerations. It is conceivable that they might coat their spacecraft with a protective layer that precisely mimics the appearance of a dusty, icy snowball. They could devise systems so closely resembling natural phenomena that differentiating them from genuine occurrences would necessitate measurements beyond our current capabilities. This isn't to assert that 3I Atlas is artificial. The overwhelming evidence indicates its natural origin. However, it serves as a potent reminder that a lack of proof isn't always proof of absence. For a civilization aiming to send probes through star systems undetected, presenting them as comets would be a remarkably astute strategy. If these probes required energy harvesting, mimicking natural outgassing processes would be an even more ingenious approach. The hypothesis of energy absorption, despite its shortcomings and the surrounding misinformation, poses a pertinent question. How would we truly know? If an object efficiently captures solar energy without producing discernible signatures distinct from natural events, what conclusive test could refute it? Yesterday's closest approach to the Sun provided a single data point. 3 Atlas behaved as expected for a natural object. Yet one observation doesn't constitute a complete picture. Another aspect, largely overlooked in mainstream reporting but extensively debated in specialized forums, concerns the orientation of 3 Atlas during its perihelion. Comets can exhibit chaotic tumbling or maintain relatively stable rotation. An object engineered for optimal solar energy collection would logically orient itself to maximize exposure to the sun, presenting its most effective collection surface during its closest approach. While we lack the high-resolution imagery to ascertain 3 Atlas's precise orientation at perihelion, its rotation period has been estimated at approximately 16.5 hours, derived from fluctuations in its brightness over time. This rotational rate is noteworthy. It's sufficiently slow for stability, yet rapid enough to distribute thermal energy relatively uniformly across its surface. If one were designing a spacecraft disguised as a comet, this would likely be the chosen speed, not so fast as to risk structural integrity, but not so slow as to cause one side to overheat while the other remains frozen. Again, this doesn't definitively prove anything, as natural objects can also possess stable rotation. Nevertheless, it's another subtle detail that contributes to the larger question of distinguishing the artificial from the natural. The solar energy impinging upon 3 Atlas at perihelion represented a significant opportunity, irrespective of the object's ability to utilize it. This is where the physics becomes truly compelling. Setting aside all speculation regarding extraterrestrial technology, the 60-plus gigawatts of power-initiated processes that we are only beginning to comprehend, the interface between solid ice and solar radiation at such intensity, creates a complex environment. Sublimation occurs certainly, but also potentially more complex chemical reactions. Organic molecules form and decompose, mineral surfaces undergo alteration, and the very structure of the ice changes as different compounds vaporize at varying rates. As 3 Atlas reemerges from behind the Sun in November, when ground-based telescopes can observe it without the disruptive solar glare, one of the initial inquiries astronomers will pursue is how it has changed. Did the perihelion heating result in brightness variations beyond expectations? Did the outgassing strip away surface layers, revealing a different composition beneath? Did it fragment under the thermal stress, a phenomenon observed in a small fraction of comets passing near the Sun? These observations will provide deeper insights into 3 Atlas's composition and its behavior under extreme conditions. And here lies the truly exhilarating aspect. We have never before encountered such an opportunity with an interstellar object. MUA, the initial confirmed interstellar visitor, was already receding when it was detected, and we never witnessed its perihelion. The second interstellar object, 2I Borisov, experienced its perihelion at 2 astronomical units, a distance far enough from the Sun that the heating effect was relatively moderate. 3 Atlas, at 1.36 astronomical units, endured significantly more intense conditions. This marks our inaugural chance to observe how an interstellar comet responds to a close solar encounter. The data we gather over the ensuing weeks as the object recedes from perihelion and gradually becomes visible again to Earth-based telescopes will contribute to answering fundamental questions about interstellar space. How does matter formed around other stars differ from that within our solar system? Does it sublimate at different temperatures? Does it possess a distinct ratio of volatile to refractory materials? Is the dust it disperses chemically unique? All these questions become answerable precisely because 3I Atlas approached the Sun closely enough to experience substantial heating. Therefore, while the energy absorption hypothesis, the notion that this object might be harnessing stellar power for some extraterrestrial purpose, is almost certainly incorrect, the dialogue it initiated is not entirely without merit. It prompted contemplation of energy requirements for interstellar travel, raised questions about identifying artificial objects in space, and underscored the immense energy available in proximity to a star, energy that could be harnessed by both natural processes and hypothetical advanced civilizations. Yesterday's perihelion passage demonstrated that 3 Atlas is behaving as comets do, absorbing energy and reacting to it through physical and chemical processes that we can observe and measure. There are no concealed solar panels or enigmatic power systems, merely ice, rock, and dust heated by our Sun, responding according to the fundamental laws of thermodynamics and chemistry that humanity has spent centuries striving to understand. Yet, The very fact that we felt compelled to investigate, to discount the extraordinary explanation before embracing the ordinary, speaks volumes about our current stage as a civilization. We are prepared for such possibilities. We are actively seeking them. And when 3 Atlas exhibited no unusual behavior at perihelion, a part of us was perhaps almost disappointed that the universe hadn't offered a more astonishing surprise. The energy remains abundant, however. 60 gigawatts struck that object yesterday, driving changes that will occupy our analysis for months to come. And as 3 Atlas continues its outward journey, carrying the thermal energy absorbed during those critical hours at perihelion, we will eagerly await what that energy reveals about this visitor from another star. What lies ahead? The true observational window. The narrative does not conclude with perihelion. In many respects, perihelion is merely the intermission. While yesterday yielded a crucial data point regarding what 3 Atlas is not, the coming months will elucidate what it truly is. The meticulously scheduled observations, the strategically positioned spacecraft, and the allocated telescope time represent an unparalleled opportunity to study an interstellar object across multiple wavelengths and from various vantage points simultaneously. Let us begin by examining the immediate aftermath of perihelion. Presently, as of this recording on October 30th, 3 Atlas is traversing the outbound phase of its trajectory. It is receding from the Sun at approximately 68 kilometers per second, still obscured from Earth-based telescopes by solar glare, but gradually increasing its angular separation from our star day by day. The geometric configuration is evolving. In approximately 12 days, around November 11th, its angular separation will be sufficient for ground-based instruments to commence tracking it in the pre-dawn sky. Consider the implications. For nearly 3 weeks, from its solar conjunction on October 21st until its reappearance in mid-November, 3 Atlas has been effectively invisible to us. We had fleeting glimpses through coronagraphs and transient views via spacecraft designed to observe the Sun's corona, but detailed spectroscopy, the precise measurements revealing composition and physical state, has been unattainable. Upon its reemergence, the object will have undergone fundamental alterations due to its perihelion passage. The crucial question is the extent of these changes. Some comets emerge from perihelion with increased brightness and activity, their internal structures disrupted by heating, their outgassing rates augmented as newly exposed ices reach the surface. Others fragment entirely, fractured by thermal stress or tidal forces. A few experience what is termed an outburst, a sudden, dramatic surge in luminosity as a pocket of volatile material rapidly vaporizes. We remain uncertain which category 3 Atlas will fall into, and this ambiguity makes November 11th one of the most anticipated dates in astronomy this year. Amateur astronomers globally have already marked their calendars. The object will be visible in the constellation Virgo, low on the eastern horizon before sunrise. A telescope of at least 8 inches will be required for detection, and even then, it will present a challenge with an expected magnitude between 11.5 and 12, depending on its post-perihelion activity. This is exceedingly faint. However, for dedicated observers who have followed this object since July, that initial glimpse after perihelion will undoubtedly be worth the early morning effort and the cold. The true excitement, however, is unfolding off-world. On November 4th, just 5 days from now, something remarkable is scheduled to occur. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, will pass within 64 million kilometers of 3 Atlas. While 64 million kilometers may seem substantial, in astronomical terms, it represents an intimate proximity. JUICE was not specifically designed for cometary studies. Its mission is to Jupiter, where it will spend years investigating Europa, Ganymede, and Callisto. Nevertheless, its flight path fortuitously brings it close to 3 Atlas in the critical post-perihelion period, a circumstance mission planners have eagerly embraced. JUICE is equipped with an impressive suite of instruments. The Janus Visible Light Imager can capture detailed images of the comet's coma structure. The MAGIS infrared spectrometer is capable of analyzing the composition of the dust and gas it is shedding. The sub-millimeter wave instrument can detect molecules invisible to optical telescopes. Perhaps most intriguing, JUICE carries a magnetometer designed to sense magnetic fields. Should 3 Atlas exhibit any unusual electromagnetic properties, any indication of artificial power systems or active electronics, JUICE would be optimally positioned to detect them. There is, however, a significant caveat. JUICE is currently utilizing its primary high-gain antenna as a heat shield, a necessary precaution due to the spacecraft's proximity to the Sun. This large dish antenna proves ideal for that purpose, but it restricts JUICE's data transmission capabilities to its smaller medium-gain antenna, resulting in an agonizingly slow data rate. Observations of 3 Atlas will be conducted in early November, but the complete dataset will not be transmitted back to Earth until February 2026. Thus, we must wait. We know JUICE is actively observing and gathering data inaccessible to other instruments from its vantage point, but we will not see its findings for 4 months. This delay is profoundly frustrating for researchers eager to understand the perihelion events, yet it also serves to heighten anticipation. Whatever JUICE has observed and measured, the data will arrive in February as a comprehensive package. If there are surprises, if 3I Atlas's post-Polonian behavior defies conventional explanation, we will learn of it all at once. Conversely, if all appears uneventfully natural, that too represents valuable information. Then, mark December 19th on your calendars. 3 Atlas will reach its closest approach to Earth at 1.8 astronomical units, approximately 270 million kilometers. While still a considerable distance and nowhere near a collision course, it will be sufficiently close for every major telescope on Earth to focus its attention. The Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories from Hawaii to Chile, all will aim to study this object. At 1.8 astronomical units, the viewing geometry will finally be favorable. We will observe it in darkness, free from solar glare, allowing ample time for deep exposures and detailed spectral analysis. December's observations will focus on several key questions. Firstly, did perihelion alter its rotational state? Asymmetric outgassing, with jets of gas erupting more forcefully from one side than another, could impart torque, thereby modifying the speed or direction of 3 Atlas's spin. Secondly, is it fragmenting? The stress of perihelion sometimes causes a comet to fracture into multiple pieces. High-resolution imagery obtained in December will be necessary to confirm this. Thirdly, what is the dust-to-gas ratio? How much solid material is 3I Atlas expelling in comparison to volatile gases? This ratio provides insights into its internal structure and composition. Furthermore, an aspect that deserves more attention, the December observations will offer our best opportunity to ascertain 3 Atlas's true dimensions. To date, size estimations have relied on brightness and assumptions about reflectivity, yielding a broad range of 5 to 20 kilometers in diameter. Brightness can be deceptive. A small, luminous object can appear similar to a large, dim one from a distance. Through precise observations in December, employing techniques such as thermal infrared measurements, we can establish the size with greater accuracy. Size is a critical factor, informing us about its mass, which in turn reveals the forces the object endured during its journey through interstellar space. Subsequently, we advance to March 16, 2026. 3I Atlas will pass within 54 million kilometers of Jupiter. The giant planet's gravitational influence will subtly alter the comet's trajectory, a final gravitational interaction before 3 Atlas departs the solar system permanently. NASA's Juno spacecraft, currently in orbit around Jupiter, will be observing. Juno is equipped with ultraviolet spectrographs capable of analyzing the comet's coma in wavelengths imperceptible to the human eye. It possesses a radio antenna that can detect any electromagnetic emissions, and its cameras can capture images of the comet against the immense backdrop of Jupiter's cloudscape, presenting a potentially once-in-a-lifetime photographic opportunity if the timing aligns perfectly. What makes the Jupiter flyby particularly noteworthy is that we will observe 3I Atlas at a much greater distance from the Sun, in a markedly different thermal environment. At Jupiter's distance, approximately 5 astronomical units from the Sun, solar heating is minimal. Any outgassing observed will be attributable to internal heat or the radioactive decay of materials within the nucleus, rather than direct solar radiation. If 3I Atlas remains active at this distance, it offers crucial information about its composition. Only the most volatile substances, such as carbon monoxide or nitrogen, can sublimate at such low temperatures. Water ice would remain frozen solid. However, there is another participant in this observational campaign that warrants greater attention. NASA's Europa Clipper spacecraft, recently launched and en route to Jupiter's moon Europa, will traverse 3I Atlas's ion tail. This is not the dust tail, composed of solid particles propelled away by solar radiation pressure, but rather the ion tail, formed by electrically charged gas molecules carried away by the solar wind. The ion tail of 3 Atlas extends for tens of thousands of kilometers, and Europa Clipper's trajectory is slated to intersect it sometime between late October and early November. When a spacecraft passes through a cometary tail, it can directly sample the particles and gases within. Although Europa Clipper was not designed as a cometary mission, lacking specialized dust analyzers or mass spectrometers optimized for cometary material, it does possess instruments capable of detecting charged particles, measuring magnetic field variations, and analyzing the plasma environment. Should 3 Atlas's tail exhibit any unusual characteristics, anomalous composition, or unexpected electromagnetic behavior, Europa Clipper may detect it. Consider the collaborative endeavor being established. Multiple spacecraft strategically positioned at diverse locations in space, observing the same object from varied angles and across different wavelengths. Ground-based telescopes are filling observational gaps, and amateur astronomers are contributing valuable sightings that professionals might otherwise miss. This represents coordinated astronomical effort on a scale rarely achieved, all focused on a singular object that we will never encounter again. Once 3 Atlas departs the solar system, it will be gone. Within a century, it will be light-years distant. In 1,000,000 years, it might traverse another star system, where perhaps future astronomers will direct their instruments toward it, pondering its origins. But here is the aspect that keeps me awake at night, in the most positive sense. Every observation we make, every spectrum we collect, every image we capture, is not solely about 3I Atlas. It is fundamentally about understanding the interstellar medium, the space between stars. This object has spent perhaps hundreds of millions, even billions of years traveling through that medium. It has been bombarded by cosmic rays, drifted through molecular clouds, and experienced conditions that nothing within our solar system has encountered since the Sun's formation, 4.6 billion years ago. The surface of 3 Atlas is a time capsule. Its interior holds a record of its formation around another star. When we study this object, we are not merely examining a comet. We are analyzing a sample of another planetary system delivered to us at no cost. There is no necessity to dispatch a probe on a century-long journey to a distant star. The sample has arrived, and over the next 6 months, we will meticulously analyze it with every available tool. Furthermore, there is the matter of what 3 Atlas might teach us regarding planetary defense. Now, before alarm bells begin to ring, let me be unequivocally clear. 3 Atlas poses absolutely no threat to Earth. Its trajectory is precisely understood, and it will not impact our planet. However, the very fact that we can track an interstellar object, predict its trajectory months in advance, and strategically position observational assets to study it, constitutes invaluable practice for the future. Should an interstellar object ever pose a threat, a statistically vanishingly remote possibility, but one that cannot be entirely dismissed, the techniques we are currently developing with 3 Atlas would be critically important. The International Asteroid Warning Network has included 3I Atlas in its observation schedule, not due to any inherent danger, but because of its unpredictable nature. a characteristic that distinguishes it from solar system objects. Comets can undergo outbursts that alter their brightness and potentially their trajectory. For planetary defense exercises, a comet prone to unexpected behavior provides ideal training. The fact that 3 Atlas is interstellar adds the complexity of unknown composition. We cannot precisely predict its behavior because we have no prior experience with material from its parent system. This training exercise is scheduled to run from November 27, 2025 through January 27, 2026. Observatories worldwide will practice tracking, reporting orbital parameters, and coordinating data sharing. From a threat perspective, this is routine. 3 Atlas is not on a collision course. However, from a preparedness standpoint, it is immensely valuable. We are learning how to collaborate effectively, share data rapidly, and refine orbital predictions in real time, all while studying an object that presents genuine observational challenges. So, when individuals inquire about what follows perihelion, the answer is comprehensive: everything. The ensuing 6 months represent the most intensive observational campaign ever directed at an interstellar object. We will acquire more knowledge about 3I Atlas between now and March than we have gathered about any previous interstellar visitor, and what we learn will not only answer questions about this specific object, but will also inform our understanding of the broader population of interstellar objects. Because here's the crucial point: 3I Atlas is not unique. It cannot be. The mathematical probabilities preclude such singularity. If we have detected 3 interstellar objects in 8 years, with our detection capabilities improving at a rapid pace, it logically follows that hundreds, if not thousands, of such objects are passing through the inner solar system annually, entirely unnoticed by us. Most are far too small, too faint, or on paths that do not bring them sufficiently close to Earth for us to detect them. Nevertheless, they exist. The expanse between celestial bodies is not a void. It is a scattering of remnants from planetary systems, expelled worlds, errant comets, and all the cosmic detritus accumulated over billions of years of stellar and planetary development. The Oumuamua probe serves as our gateway to understanding this cosmic population. Every measurement we gather enhances our comprehension of what interstellar space truly entails. As we develop more advanced telescopes, deploy more sensitive instruments, and improve our ability to detect subtle, swiftly moving objects, we are certain to discover more. The Vera C. Rubin Observatory, which commenced operations this year, is anticipated to identify dozens, perhaps even hundreds, of interstellar entities within the coming decade. Each discovery will contribute a data point, refining our understanding. Furthermore, each will carry with it the faint, yet ever-present possibility of unforeseen wonders that currently elude our imagination. The observations planned for the subsequent 6 months transcend mere data acquisition. They represent exploration in its purest form. We are extending our reach beyond our solar system without physically departing it, studying celestial samples delivered to us by the cosmos itself. Regardless of whether Oumuamua proves to be entirely unremarkable or unveils astonishing enigmas, the process of its investigation is pushing the boundaries of our observational and cognitive capabilities. This is what lies ahead. Not definitive answers, but rather more profound questions, more intricate enigmas, and a clearer perspective on both our knowledge and the vast unknowns within our cosmic vicinity. The lingering anomalies, 8 red flags that remain unexplained. The object's closest approach to the Sun occurred without incident, yet this does not negate the peculiar characteristics that initially drew widespread attention to Oumuamua. The object still registers a 4 on the Loeb scale, a measurement system specifically devised to quantify the degree of anomaly exhibited by an interstellar object. A score of 0 signifies a definitively natural origin, while a 10 indicates a definitively technological one. A score of 4 occupies an unsettling middle ground, natural yet peculiar, ordinary, but possessing enough eccentricities to warrant a second look. and these peculiarities have not vanished simply because the mothership hypothesis failed its most significant test. Let us systematically examine them, for this is where the genuine scientific inquiry intensifies. These are not flights of conspiracy or idle speculation. They are documented observations that do not neatly fit our existing models of how interstellar comets ought to behave. 8 anomalies, each individually explicable, yet collectively, they paint a picture of an object that challenges some of our fundamental assumptions about the universe beyond our solar system. Anomaly number 1, the trajectory alignment. Oumuamua entered our solar system on a path that remains within 5 degrees of the ecliptic plane. This is the planar region where all the planets trace their orbits, the very plane that defines the solar system's structural framework. Now, if interstellar objects arrive from arbitrary directions, distributed uniformly across the celestial sphere, the likelihood of any given object aligning this closely with the ecliptic is approximately 0.2%, or 1 in 500. It is not impossible, but it is certainly uncommon. The counterargument, and it is a valid one, posits that survey telescopes like Oumuamua preferentially scan regions near the ecliptic because that is where the majority of solar system objects are located. If one is searching for asteroids that could pose a threat to Earth, the vast majority of observational effort is directed towards the ecliptic zone. Consequently, it is conceivable that we are biased towards discovering interstellar objects within this plane, merely because it is where our most meticulous observations are concentrated. This would be a selection effect, not a genuine anomaly. However, here is the crucial point. Oumuamua was sufficiently luminous and proximate that even a survey focusing on other areas would likely have detected it. The alignment is indeed real, even if its statistical significance is subject to debate. Anomaly number 2, the peculiar tail observed during July and August. Most comets exhibit tails that point away from the sun, propelled by solar radiation and the solar wind. Certain comets develop what appears to be an anti-tail, a projection that seems to point towards the sun. However, this is typically an optical illusion arising from the viewing perspective. One is observing a curved tail edge on, and foreshortening makes it appear to be directed in the opposite direction. Yet, the anti-tail of Oumuamua, as observed by the Nordic Optical Telescope and other instruments, displayed characteristics inconsistent with the standard geometric explanation. The observed jets appeared to be genuinely directed towards the sun, driven by outgassing from the sunlit side of the nucleus. Subsequently, the anti-tail vanished, and a conventional tail formed. This transition from sunward jets to a regular anti-solar tail suggests a shift in the dominant ices responsible for the outgassing. Initially, when the comet was farther from the sun, carbon dioxide ice was sublimating most vigorously. Carbon dioxide sublimes at lower temperatures than water ice, and the pressure exerted by the escaping gas could generate jets that deviate from the typical pattern. As Oumuamua drew closer to the sun, water ice began to play a more significant role, and the tail structure normalized. This explanation is plausible, but it necessitates that Oumuamua possessed an unusual ratio of carbon dioxide to water. This leads us to the subsequent anomaly. Anomaly number 3, its composition. Spectroscopic analysis conducted by the James Webb Space Telescope revealed that 3I Oumuamua exhibits the highest carbon dioxide to water ratio ever documented in a comet. The disparity is substantial. Comets within our solar system typically contain significantly more water than carbon dioxide. However, 3I Oumuamua presents the inverse scenario. This observation provides a crucial insight. The object originated in an exceedingly cold environment, cold enough for carbon dioxide ice to condense and accumulate in substantial quantities. This suggests formation in the outer regions of its parent planetary system, or possibly within a molecular cloud that was colder than the one that gave rise to our solar system. Furthermore, the composition story includes more peculiar details. The detection of nickel emissions early in Oumuamua's approach without corresponding iron emissions is genuinely perplexing. In solar system objects, nickel and iron tend to be found together. They are both siderophile elements, meaning they have a strong affinity for metals. When vaporizing a rock containing nickel, iron vapor is almost invariably present as well. Yet, Oumuamua displayed pronounced nickel emission lines in its spectrum with negligible iron. How can this be explained? One possibility is that the nickel is incorporated into compounds that vaporize at lower temperatures than iron-bearing minerals. Perhaps it is present in sulfides or organic complexes that dissociate more readily than metallic alloys. Another hypothesis suggests that the surface layer of Oumuamua is enriched in nickel relative to iron due to some process that occurred during its interstellar transit. Cosmic ray bombardment can alter surface chemistry. Preferential sputtering could lead to the removal of certain elements at a faster rate than others, but at this point, we are engaging in speculation. The fundamental takeaway is that the signature of nickel unaccompanied by iron does not align with our expectations, and we currently lack a fully satisfactory explanation. Anomaly number 4. Estimates of its size and mass. Oumuamua is substantial, remarkably so for an interstellar object. Diameter estimates range between 5 and 20 kilometers, with the most probable values clustering around 10 to 14 kilometers. This renders it approximately 1 million times more massive than Oumuamua, and roughly 1,000 times more massive than Comet Borisov. Is this physically impossible? No. Larger objects are statistically rarer, but they do exist. The pertinent question is whether the size distribution inferred from our exceedingly small sample of 3 interstellar objects aligns with statistical predictions. Some models concerning the ejection of objects from planetary systems indicate that smaller debris should vastly outnumber larger fragments. We should encounter more objects like Oumuamua, but thus far, we have observed one minuscule object, one of moderate size, and one large object. This distribution does not conform to the predictions of current models. Either our models are flawed, we have been extraordinarily unfortunate in our detections to date, or there is an aspect of the detection process that inadvertently favors the discovery of larger interstellar objects than we initially assumed. This remains an open question. Anomaly number 5. Its velocity. Oumuamua is moving at a considerable speed, 68 kilometers per second relative to the Sun at its perihelion. Its velocity relative to the local standard of rest, which represents the average motion of stars in our galactic neighborhood, is even higher. This velocity surpasses that of the 2 preceding interstellar objects. Oumuamua traveled at 26 kilometers per second, and Comet Borisov at 32. Oumuamua more than doubles these figures. High velocity implies either an extended period of travel or a significant energetic impetus from its point of origin, or possibly both. The speed also influences the backward tracing of its trajectory. The faster an object moves, the more susceptible its path is to minor gravitational disturbances. Interactions with stars, even those at considerable distances, can deflect a rapidly moving object more readily than a slower one. Researchers have attempted to reverse engineer Oumuamua's path through the galaxy to ascertain its origin. The trail grows indistinct after approximately 10 million years. Beyond this point, the uncertainties become too significant. We know it originated from the direction of Sagittarius, towards the galactic center, but billions of stars reside in that sector. Pinpointing its parent system is likely an insurmountable task. Anomaly number 6. The timing of its arrival and planetary encounters. This anomaly is subtle and easily dismissed as coincidence, but it merits noting. Oumuamua's trajectory brings it within tens of millions of kilometers of Mars, Venus, and Jupiter, while maintaining a sufficient distance from Earth to render it challenging to observe during its most active phase. This confluence of close approaches to 3 major planets, coupled with its obscuration from Earth during perihelion, carries a probability of less than 1%, according to some calculations, perhaps as low as 0.5%. Does this indicate deliberate design? Almost certainly not. However, it does imply that if one were orchestrating an optimal trajectory for a reconnaissance mission, a path very similar to Oumuamua's actual course would be chosen, sufficiently close to study multiple planets, yet sufficiently distant from the dominant inhabited world to evade immediate detection. The timing of its arrival at perihelion would coincide with a period when the planet's telescopes are largely unable to observe it. This aligns remarkably well with such a profile, which is either an astonishing coincidence or a stark reminder that humans possess a remarkable aptitude for discerning patterns, even within random data. Anomaly number 7. The absence of certain anticipated features. This constitutes an argument based on the lack of evidence, which is inherently challenging, but please bear with me. Comets within our solar system frequently exhibit signs of fragmentation, particularly after close solar passes, resulting in detached pieces and split nuclei that form families of related objects following similar trajectories. Oumuamua, subjected to intense heating and tidal stress at perihelion, did not fragment, at least not to our current observations. It remained intact. This suggests it is either structurally more robust than typical comets, smaller and denser than we perceive it to be, or bound together by forces beyond mere weak gravitational self-attraction and frozen ices. We have also not witnessed the dramatic brightening that sometimes accompanies perihelion. Some comets experience outbursts, sudden increases in luminosity by several magnitudes as internal pressure builds and explosively releases. Oumuamua brightened predictably and smoothly, without any explosive events. While this is not necessarily anomalous, it is noteworthy given the object's unusual composition and the intensity of the solar heating it endured. Anomaly number 8. Its sustained activity. Oumuamua began exhibiting cometary activity, a visible coma, and indications of outgassing when it was still approximately 4.5 astronomical units from the Sun. This is exceptionally distant. Most solar system comets do not become active until they approach within 3 astronomical units. The early activity suggests that Threequartz Oumuamua contains highly volatile materials, ices that sublimate at exceedingly low temperatures, such as carbon monoxide, potentially nitrogen, and methane. These are the ices capable of driving activity at vast distances. However, the extent of the observed activity, the luminosity of the coma, implies a considerable quantity of this material, exceeding our typical expectations. Now, let us step back and consider the overarching question. Do these 8 anomalies collectively signify something of great importance? Or are they merely the expected variations inherent in a population of objects originating from diverse formation environments? Every planetary system is unique. The disk of gas and dust that formed around Oumuamua's parent star possessed its own temperature profile, its own composition, and its own dynamics. We should not anticipate objects from other systems to precisely mirror those from our own. Some degree of variation is not only expected but guaranteed. But at what point does variation become excessive? When does unusual transition to inexplicable? This is the question that continues to engage researchers with regard to Oumuamua, even after the mothership hypothesis faltered. Because setting aside all discussion of extraterrestrial technology and disregarding conspiracy theories and sensationalism, we are left with an object that genuinely challenges some of our established models. And it is through challenges that science advances. One formulates a model that accounts for all observed phenomena. Subsequently, a new observation emerges that does not quite fit. This necessitates refining the model, expanding its parameter space, and acknowledging that reality is often more complex than our equations suggest. Oumuamua represents that complex reality. It is not impossible, nor is it inexplicable. However, it is unequivocally pushing the boundaries of our expectations for interstellar comets. And that is valuable. Every assumption we make about the universe is predicated on limited data. We have studied thousands of comets from our own solar system, but only 3 from beyond its confines. This is insufficient to confidently ascertain what constitutes normalcy and what does not. Perhaps Oumuamua is unusual when compared to solar system comets, but perfectly typical for comets originating from other systems. Perhaps its parent star system had a different composition, a distinct history, or unique conditions during planetary formation. Or, and this is the possibility that maintains the intrigue of the anomalies, perhaps there are aspects of the interstellar environment that alter objects in ways we do not yet fully comprehend. Cosmic rays can modify surface chemistry. Interstellar dust can erode and reshape objects over millions of years. The object we observe today might be significantly different from the object that departed its parent system billions of years ago. It has undergone processing, weathering, and transformation during its journey in ways that no solar system object has experienced. The 8 anomalies do not prove anything extraordinary. They do not revive the alien hypothesis, but they do demonstrate that Oumuamua has more to impart to us. The object is a puzzle, and puzzles are captivating precisely because they resist facile explanations. Over the ensuing months, as further data becomes available, some of these anomalies may be resolved. We might discover that the nickel emissions were a measurement artifact. We may obtain more precise size estimates that render its mass less extraordinary. We might observe fragmentation that we previously overlooked. Or we may uncover new anomalies, novel properties that do not align with our models, providing further impetus to broaden our understanding of what is conceivable in the cosmos. This is the inherent beauty of conducting science at the frontier. One does not know what one will discover. One makes observations, measures meticulously, scrutinizes instruments and assumptions, and occasionally, very occasionally, the universe presents something that compels a reevaluation of everything previously held as known. Oumuamua has not yet reached that point, but it has exhibited enough peculiarities that we find ourselves unable to entirely look away. And that is more than sufficient to sustain the compelling nature of its story as we await further developments. Concealed behind the sun, the perfect window for conspiracy. There is a profoundly unsettling aspect to the timing. Even for a skeptic, even with a complete understanding of orbital mechanics, 3I Oumuamua reached solar conjunction on October 21st. 8 days later, it achieved perihelion. Throughout this entire period, extending to approximately November 11th, the object was effectively invisible to Earth-based telescopes. The geometry is straightforward. When an object is within about 10 to 15 degrees of the sun in our sky, its glare renders all else undetectable. It is impossible to direct a ground-based telescope towards it without risking damage to the instruments and obtaining nothing but scattered sunlight. Therefore, the most critical juncture in Oumuamua's transit through our solar system, the moment when any propulsion system would be most efficacious, when any course corrections would require minimal fuel, when any hypothetical mini-probes would be most optimally released, occurred at a time when we were unable to observe it. We had coronagraphs and spacecraft positioned away from Earth's solar line, but the detailed, continuous observation one would desire for such a crucial event was impossible. And this impossibility fueled every conspiracy theory surrounding the object. Was the timing coincidental or deliberate? This was the question that repeatedly surfaced in forums, in YouTube comments, and in breathless social media posts. Because if one were an advanced civilization planning a reconnaissance mission, aiming to study a planetary system while minimizing the likelihood of detection, one would carefully select its trajectory. One would target perihelion at a time when the system's primary observers, those possessing the most sophisticated instruments, had their view obstructed by their own star. One would exploit the natural blind spot created by orbital geometry. The mathematical analysis of this scenario is genuinely fascinating, even as it leads to conclusions that are almost certainly incorrect. The alignment with the ecliptic positions Oumuamua within the plane of planetary orbits. The velocity and timing bring it to perihelion in late October, precisely when Northern Hemisphere observatories are transitioning to winter viewing conditions, and the object is in the most disadvantageous position for observation. The close approaches to Mars, Venus, and Jupiter suggest a trajectory designed to sample multiple planets, and the Earth blackout during perihelion creates a window for potential undetected activity. Calculating the probability of all these factors occurring by chance yields figures that sound impressive, less than 1%, perhaps as low as 0.2%, depending on the precise definition of parameters. However, herein lies the challenge with probabilistic arguments. When dealing with a sample size of 1, when examining the trajectory of a single object, one cannot meaningfully compute odds. Every specific trajectory through a solar system is improbable. The path that Oumuamua happens to follow is neither more nor less likely than millions of other potential routes. This is a classic instance of the Texas sharpshooter fallacy. One identifies a pattern within the data and then calculates the unlikelihood of that specific pattern, without accounting for all the other patterns that could have emerged if the data were different. If Oumuamua had passed closer to Earth during perihelion, we would be discussing the suspicious nature of an interstellar object approaching the sole inhabited planet so closely. If it had avoided all the major planets, we would be examining how its trajectory was clearly engineered to remain undetected by not approaching any potential sensor-equipped bodies. Significance can be found in almost any outcome if one is actively seeking it. However, let us acknowledge the human element involved, as it is significant. The feeling of being visually impaired during a critical moment is profoundly disquieting. We had spent 4 months observing this object, tracking it, measuring it, debating its potential nature, and then, at the crucial moment, it vanished behind the sun, compelling us to wait. This period of waiting, from October 21st to mid-November, created a vacuum into which speculation rapidly flowed. When direct observation is impossible, imagination takes over, conjuring scenarios ranging from plausible to utterly absurd. A reasonable explanation, one even the most doubtful had to acknowledge, was that the comet's closest approach to the Sun, its perihelion, could induce unforeseen transformations. Comets are known to fracture, to erupt with sudden bursts of activity, and their physical makeup can shift in ways that become evident only hours or days following their nearest pass. If 3 Atlas engaged in some striking alteration during perihelion, one that modified its visual presentation or its orbital path, we would not have immediate knowledge of it. Confirmation would necessitate a waiting period until it reappeared within our observational range. This is not a matter of unfounded suspicion. It is merely an acknowledgement of the inherent constraints in our capacity to observe. Less probable scenarios involved deliberate propulsion. The concept of optimal efficiency, where expending fuel at peak velocity yields the greatest performance, applies universally, whether to natural cosmic phenomena or manufactured propulsion systems. Should 3 Atlas have been programmed to alter its course, to deploy any component, or to undertake any action requiring substantial energy expenditure, perihelion would represent the ideal juncture for such a maneuver. The fact that our observation capabilities were diminished during that specific interval did not itself cause any such action, but it did mean that if an event transpired, we would be privy to its repercussions rather than the event itself. And then, there were the truly outlandish hypotheses. These posited that 3 Atlas might leverage its passage near the Sun to mask some form of electromagnetic broadcasting, or to absorb solar energy for systems beyond our current detection capabilities, or even to disperse clouds of microscopic drones, too minute to be seen individually, but potent enough to traverse the solar system. These notions veer into the realm of speculative fiction rather than empirical science. However, their veneer of technical terminology lent them an air of credibility for some, making them surprisingly persuasive. It is noteworthy how the established astronomical community reacted to such conjecture. For the most part, they remained silent. Professional astronomers continued their dedicated work, conducting observations when feasible, meticulously analyzing collected data, and disseminating their findings through scholarly publications. They did not feel compelled to engage in refuting every fanciful theory circulating on social media, as, frankly, it would be an exercise in futility. If an individual is convinced that 3 Atlas is an extraterrestrial mothership, No amount of empirical data demonstrating its natural behavior will sway their conviction. The conspiracy narrative simply adapts, asserting that the data is fabricated, that the scientists are complicit, and that the truth is being deliberately concealed. Nevertheless, a select few researchers did actively address the questions surrounding the timing and visibility of the comet. They highlighted that solar conjunction, a period when an object is obscured by the sun from Earth's perspective, is a commonplace occurrence for celestial bodies within the inner solar system. Mars undergoes this phenomenon, as does Venus, and asteroids experience it with regularity. The circumstance of 3 Atlas experiencing conjunction concurrent with its perihelion is indeed unusual, but not entirely without precedent. More significantly, this period was not a complete observational void. We possessed spacecraft-based observations and data from coronagraphs. The object was not entirely undetectable, merely challenging to observe from Earth's surface. The coronagraph observations, in particular, are quite striking upon closer inspection. Images procured by SOHO's LASCO C2 and C3 cameras depicted 3 Atlas as a faint, indistinct mass traversing the observational field. The polarimeter to unify the corona and heliosphere instrument also registered its presence. While these images lack the high resolution necessary to reveal intricate surface details or structural characteristics, they are sufficiently precise to confirm the object's position and luminosity, thereby verifying its location and general behavior as anticipated. This very fact undermines the narrative of an unimpeded window for clandestine activities. If 3 Atlas were to execute any covert operation during perihelion, it would necessitate an action that did not significantly alter its position or brightness, as these parameters were subject to partial but continuous monitoring. A substantial course adjustment would be readily apparent in the trajectory data. A dramatic release of energy would manifest as a detectable change in brightness. Consequently, the observational window was not as perfectly opaque as conspiracy theorists imagined. Furthermore, the role of amateur astronomers warrants consideration. These dedicated individuals, operating independently of governmental agencies or academic institutions, claim to have observed 3 Atlas at low solar elongations, employing meticulous techniques to mitigate the sun's glare. While these observations are inherently difficult to corroborate and the resulting imagery is, at best, marginal, they do exist. If a cover-up were indeed in effect, it would necessitate the complicity of the global community of amateur astronomers, a logistical improbability of immense scale. Amateur observers, by their very nature, relish the opportunity to discover phenomena that elude professional detection. The concept of the conspiracy window, however, persists because it resonates with a fundamental truth. Our observational coverage of the solar system is not exhaustive. We are incapable of monitoring every celestial object at all times. There are inherent gaps, intervals during which objects are positioned in ways that render them difficult or impossible to observe from Earth. 3 Atlas happened to reach perihelion during one such interval. For individuals inclined to discern patterns and intent in coincidental occurrences, this situation proved exceptionally provocative. It is worthwhile to examine why the narrative of being hidden behind the sun became so compelling. A portion of its appeal is cinematic. It evokes scenes from science fiction films. An alien probe synchronizes its approach to evade detection, utilizing the sun as a screen while executing its clandestine mission. It is a compelling narrative, replete with tension and intrigue, tapping into our cultural archetypes of aliens as secretive and calculating beings. However, it also reflects a deeper undercurrent, a form of cosmic apprehension stemming from the awareness of our limited observational reach. The universe is vast, space is immense, and the distances involved are staggering. Even within our own solar system, with all our sophisticated telescopes and spacecraft, we can only perceive a minute fraction of the ongoing events at any given moment. This realization is both humbling and disconcerting. What are we failing to perceive? What phenomena are unfolding at this very instant that we lack the instruments or the vantage point to witness? The perihelion passage of 3 Atlas behind the sun, serve to crystallize this underlying anxiety into a specific event, framed within a defined temporal scope. And here lies an uncomfortable verity. If an advanced civilization aspired to conduct covert surveillance of our solar system, they likely could. This capability would stem not from any ingenious manipulation of orbital mechanics, but simply from the sheer immensity of space and the inherent limitations of our observational technologies. We have identified asteroids traversing the space between Earth and the Moon, occasionally only after they have already passed. We miss comets until they have advanced considerably into the inner solar system. While our observational surveys are continuously improving and our instruments are becoming increasingly sensitive, we are far from omniscient. The solar system does not exist under a regime of comprehensive surveillance. Therefore, when 3 Atlas disappeared behind the Sun, becoming difficult to observe during the most critical phase of its visitation, this was not an indication of deliberate design. Rather, it was a testament to our inherent limitations. And perhaps this is what most disturbs people, not the possibility of extraterrestrial presence, but the certainty that we might not necessarily detect it, even if it were occurring. The narrative of being hidden behind the Sun speaks less to the nature of 3 Atlas, and more to our intrinsic human desire for knowledge and our palpable frustration with the boundaries of our observational capabilities. The encouraging news, for those seeking it, is that this period of obscurity is drawing to a close. In less than 2 weeks, 3 Atlas will once again be visible to ground-based telescopes. We will ascertain the effects of perihelion on its structure. We will measure its trajectory with precision. We will meticulously analyze its spectral signature, searching for any shifts in its composition or activity. The data will arrive, and this data will furnish definitive answers. It may confirm that no extraordinary events transpired, or it may unveil surprises that necessitate novel interpretations. Regardless, the period of enforced blindness will conclude, and when it does, when we possess clear observations of 3 Atlas post-perihelion, we will be able to reflect upon this interval and evaluate its true significance. Was it the perfect window for covert operations, the moment an alien probe executed its mission undetected? Or was it merely an unfortunate confluence of orbital mechanics, a stark reminder that observation demands patience and that events unfold irrespective of our gaze? The latter is almost certainly the case. However, the very fact that the question ignited such widespread discourse speaks volumes about our current stage as a civilization. We are receptive to discovery. We actively search for it. And when our observation is impeded, we naturally wonder what we are missing. The peculiar reversal of the anti-tail phenomenon. Was it propulsion or simply physics? During July and August, while 3 Atlas remained a considerable distance from the Sun, astronomers noted an unusual characteristic. The comet exhibited a tail, as anticipated, but this tail appeared to be oriented incorrectly. Instead of extending away from the Sun, propelled by solar radiation and the solar wind, material seemed to be moving towards the Sun. This phenomenon is known as an anti-tail. Now, anti-tails are not entirely unknown. They can arise as an optical illusion when the edge of a curved dust tail is viewed head-on. The perspective can create the impression of the tail moving sunward, when in reality it is merely part of a larger structure that is being observed from an unfavorable angle. However, the anti-tail displayed by 3 Atlas did not conform to this explanation. Multiple observations from diverse viewpoints confirmed its reality. High-resolution imagery captured by the Nordic Optical Telescope in the Canary Islands revealed distinct jets of material emanating from the sunward side of the nucleus. Other observatories corroborated these findings. This was not a trick of perspective. It was actual matter moving in a direction contrary to expected cometary behavior. For a period of several weeks, before a satisfactory explanation emerged, it presented as a genuinely anomalous occurrence. Speculation commenced immediately. If material was indeed moving towards the Sun, some force must be at play. Solar radiation repels objects from the Sun. Therefore, whatever was driving this motion had to be an alternative influence. Perhaps it was outgassing pressure from the night side of the nucleus, or jets induced by rotation that happened to point sunward by chance, or, according to the more imaginative theories, a thrust originating from some form of propulsion system. The anti-tail rapidly became the primary piece of evidence for those asserting that 3 Atlas was under active control. Subsequently, in late September, the anti-tail vanished. By early October, 3 Atlas had developed a conventionally oriented tail, extending away from the sun, as is typical for cometary tails. The transition from this unusual manifestation to a normal appearance occurred gradually over several weeks. Once this transformation was complete, the object presented as any other comet approaching perihelion. The anomaly appeared to have resolved itself, yet the fundamental question persisted. What had caused the anti-tail in the first place, and why did it subsequently revert to normal behavior? The explanation, once researchers elucidated it in detail, proved to be both fascinating and entirely natural. It is rooted in the varying sublimation temperatures of different ices at different distances from the Sun. When 3 Atlas was situated beyond 3 astronomical units from the Sun, the solar heating was relatively subdued. Water ice, which constitutes the majority of most cometary nuclei, remains frozen at such distances. However, carbon dioxide ice, which sublimates at significantly lower temperatures, can begin to vaporize even when the comet is far from the Sun. 3 Atlas, possessing an unusually high ratio of carbon dioxide to water, had an abundant supply of carbon dioxide available. This is where the situation becomes particularly interesting. The sublimation of carbon dioxide generates pressure in a manner distinct from that of water sublimation. CO2 can accumulate beneath a surface layer, creating pressurized gas pockets that eventually breach the surface and erupt outward as jets. The direction of these jets is contingent upon the locations of most active CO2 sublimation, which in turn depends on which portion of the nucleus is oriented towards the Sun. For a comet rich in CO2 and exhibiting a specific rotational orientation, it is possible to generate jets that appear to point sunward, as they erupt from the illuminated side and are channeled by surface topography. As 3 Atlas drew nearer to the Sun and temperatures increased, water ice began to dominate the outgassing process. Water behaves differently than CO2, leading to more diffuse sublimation and less propensity for dramatic jetting. Furthermore, as water ice typically comprises a greater proportion of the nucleus's outer layers than CO2, its significant sublimation effectively overshadows the contribution from CO2. The shift from CO2-dominant to water-dominant outgassing closely coincided with the disappearance of the anti-tail and the emergence of normal tail structures. This explanation aligns flawlessly with the observed data, accounting for the timing, the morphology, the transition, and requiring no more than well-established principles of thermodynamics and gas dynamics. However, this explanation, while natural and convincing, also underscores that 3 Atlas possesses an atypical composition. That elevated CO2 to water ratio is not standard for objects within our solar system. Therefore, while the anti-tail does not provide evidence of artificial construction, it does confirm that this object originated under conditions different from those that formed our local comets. The anti-tail reversal also served as a cautionary illustration of how swiftly conjecture can outpace empirical evidence. In the weeks when the anti-tail was observable but not yet understood, the hypothesis of reverse thrust gained considerable traction. Videos were produced and diagrams were created depicting how a spacecraft might utilize directed gas jets for deceleration. The principles of orbital mechanics were applied to calculate the requisite thrust to achieve the observed effects. Some of this analysis was remarkably sophisticated, undertaken by individuals possessing expertise in physics and engineering. However, all of this speculation was predicated on incomplete information. The observers documenting the anti-tail were also gathering spectroscopic data, measuring the emitted gases, and analyzing the dust-to-gas ratio. From the outset, this data pointed towards the presence of CO2. Nevertheless, the comprehensive analysis of spectroscopic data is a time-consuming process, It necessitates careful consideration of instrumental factors, calibration procedures, and atmospheric absorption for ground-based observations. The complete picture gradually emerged over a span of weeks, not days. In the interim, the void of a definitive explanation was filled with alternative theories. This pattern recurred throughout 3 Atlas's approach, an observation that initially appears anomalous, followed by a period of uncertainty while researchers work to comprehend the phenomenon, leading to speculative hypotheses that often veer into the extreme, and ultimately culminating in an explanation that, while consistent with known physics, may nevertheless reveal intriguing aspects of the object's intrinsic properties. The anti-tail was merely the most visually arresting example of this phenomenon. It is particularly interesting to observe how the anti-tail controversy unfolded across different observational communities. Professional astronomers, for the most part, adopted a stance of patient observation, stating, "Let us await the data." Amateur astronomers became divided, with some engaging in excited speculation and others favoring cautious interpretation, while social media platforms descended into full-blown conspiracy theories, treating the anti-tail as irrefutable proof of artificial manipulation. The identical observations, when interpreted through differing perspectives, yielded dramatically divergent conclusions. This situation offers a valuable lesson regarding both the scientific process and public communication. When researchers observe something they cannot immediately comprehend, they face a choice. They can state, "We do not yet know. We must gather more data." Alternatively, they can engage in public speculation about potential explanations, including those that are unconventional. The majority of researchers opt for the former approach, as speculation devoid of supporting data is frequently erroneous, and public missteps can be embarrassing. However, this cautious methodology creates an informational vacuum. If scientists refrain from speculating, others will, and these individuals may not possess the same rigor in adhering to evidence or the same understanding of what constitutes plausibility. Avi took a different tack with 3 Atlas, engaging in public speculation, frequently proposing hypotheses ranging from the conservative to the extraordinary. In Lee's interpretation, the anti-tail could be a natural phenomenon or a product of engineering. He presented both possibilities, arguing that the exotic explanation should not be dismissed solely due to its unsettling nature. This approach made him a focal point for criticism from other astronomers, who felt he was lending undue credibility to improbable scenarios. However, it also positioned him as the public face of 3 Atlas research, the individual contacted by journalists seeking commentary. The debate surrounding Lee's approach reveals an inherent tension in how science interacts with the public. On one hand, there is a desire to communicate uncertainty honestly. Science is not characterized by absolute certainty, but rather by probabilities and confidence intervals. On the other hand, nuanced distinctions are not easily conveyed in headlines. A scientist suggesting a 5% probability of an artificial origin might be reported as scientists hinting at alien probes. The subtlety is lost, and the public is left with an impression that diverges from the scientist's intended meaning. The anti-tail served as a perfect case study. When Lee alluded to the possibility that the anti-tail could be consistent with thrust, he was making a statement that was technically accurate. If one were to observe a spacecraft employing gas jets for deceleration, the visual manifestation might bear a resemblance to what was observed. However, the probability that this explanation was correct, compared to the probability that it was simply an unusual manifestation of CO2 sublimation, was never equal. The natural explanation consistently held a higher likelihood. But once the artificial thrust concept was introduced, it gained its own momentum. By the time the CO2 sublimation explanation was confirmed, the impact on public perception had already taken hold. Those predisposed to believe in the artificial hypothesis viewed the subsequent explanation with suspicion. Why should the CO2 narrative be trusted? Perhaps it was a fabricated cover story, and the genuine data was being concealed. Conspiracy theories exhibit a remarkable resilience to contradictory evidence, as they can readily incorporate such evidence as further proof of the conspiracy itself. One cannot effectively argue with someone who maintains that the data itself is fictitious. However, for individuals who engage with evidence in good faith, the anti-tail narrative is, in fact, deeply satisfying. It demonstrates the scientific method functioning precisely as it should. An unexpected observation is made. Hypotheses are proposed, encompassing even the extraordinary. More data is collected. Rigorous analysis is conducted. A conclusion is reached that aligns with the evidence and does not necessitate the invocation of new physical principles or extraterrestrial intervention. In the process, something new is learned about the object in question. In this instance, we learned that 3 Atlas possesses an unusual composition, which results in peculiar behavior, thereby offering insights into its formation environment and circumstances. The anti-tail also underscores the critical importance of patience in astronomical pursuits. Modern instrumentation can acquire data with remarkable speed, but the subsequent analysis demands time. An image can be downloaded in mere seconds, but understanding its full implications might require weeks or even months. During this analytical phase, the public narrative often progresses at an accelerated pace. Conclusions are prematurely drawn, narratives solidify, and by the time the meticulous analysis is finalized, many individuals have already formed their definitive opinions. This is not a novel challenge. It has been a recurring theme throughout the history of astronomy. When Percival Lowell observed what he believed to be canals on Mars through his telescope, he became convinced that they were artificial irrigation systems constructed by a Martian civilization. Other astronomers expressed skepticism, but Lowell commanded a significant platform and substantial funding. The canal hypothesis persisted for decades until superior telescopes revealed that these perceived canals were optical illusions, artifacts of how the human eye and brain process low-contrast features at the very limits of visual perception. Yet, throughout that entire period, the concept of Mars as an inhabited world captured the public imagination. The anti-tail phenomenon of 3 Atlas represents our contemporary parallel. While not as dramatically impactful as Martian canals, nor as culturally significant, it follows the identical pattern. An ambiguous observation is made. It is interpreted through the lens of pre-existing desires or expectations. Corrections based on superior data are resisted, and eventually, albeit grudgingly, the more mundane explanation is accepted. The anti-tail was a consequence of CO2 sublimation, creating unusual jet structures. It appeared peculiar, and indeed it was peculiar. But peculiarity is not synonymous with artificiality. The dissipation of the anti-tail and the subsequent development of typical tail formations as 3I Atlas neared its closest approach to the Sun further solidifies the notion that it is a naturally occurring celestial body. If the object were employing propulsion for deceleration or course correction, why would such thrust cease precisely at the juncture where maneuverability would be most advantageous? Logic dictates that any system designed for fuel expenditure would prioritize such actions during perihelion, not prior. This timing contradicts expectations for an artificial construct, but aligns perfectly with the anticipated behavior of a comet undergoing shifts in sublimation patterns as it heats up. Consequently, the reversal of the anti-tail, which for a brief period seemed indicative of something extraordinary, ultimately served as evidence of something merely uncommon. A comet rich in carbon dioxide exhibiting characteristics typical of such objects. This event broadened our comprehension of cometary diversity, demonstrating that interstellar visitors can possess traits that stretch the limits of our observational experience, yet without defying established physical laws or necessitating novel theoretical frameworks. It simply demanded meticulous observation and diligent analysis. Perhaps, then, the true narrative of the anti-tail is not its potential implication of artificial propulsion, but rather its absence. The universe, it seems, is sufficiently enigmatic, varied, and surprising without the need to posit extraterrestrial intervention. 3I Atlas can simply be a peculiar, carbon dioxide-rich interstellar comet originating from a planetary system with chemical compositions distinct from our own. and that in itself is remarkable. It does not require designation as a spacecraft to warrant our profound interest. Its scientific merit is compelling on its own terms. Avi Loeb's 40% gamble. When Harvard encountered hysteria. Avi Loeb holds the distinguished position of full professor of astronomy at Harvard University, having previously served as the chair of the astronomy department and as the founding director of the Black Hole Initiative. His academic contributions include hundreds of articles published in peer-reviewed journals, covering a wide spectrum of topics from cosmology and black holes to the genesis of the universe. By all conventional metrics, he is recognized as a serious scientist possessing substantial credentials. Nevertheless, in the months preceding 3I Atlas's perihelion, his public persona evolved. He became a focal point of intense discussion, a provocateur, and the prominent advocate for a hypothesis that the majority of his professional peers considered improbable at best and utterly preposterous at worst. The hypothesis itself is straightforward. Loeb estimated a 30 to 40% likelihood that 3I Atlas was not entirely natural in origin, positing it not as a conventional comet, but as a technological artifact, potentially an alien probe, or even a mothership capable of deploying smaller exploratory craft. Loeb has largely exercised caution in framing this as a possibility, rather than a definitive conclusion, presenting it as a hypothesis meriting investigation, not a settled fact. However, this subtlety has frequently been lost in its dissemination. When a Harvard professor suggests a 40% probability that an object might be alien technology, it naturally commands attention. When that same professor participates in the Joe Rogan Experience, one of the world's most widely listened to podcasts, and dedicates 2 hours to discussing the alien probe hypothesis, the conversation transcends niche scientific discourse to become a widespread cultural phenomenon. This is precisely what transpired with 3I Atlas. Loeb's readiness to publicly explore the hypothesis of an artificial origin transformed a legitimate astronomical object into a test case for our societal perceptions of extraterrestrial intelligence. The 40% figure is particularly striking due to its dual nature. It is both specific and inherently unverifiable. How does one quantify the probability of an interstellar object being artificial? What serves as the baseline? What is the expected ratio of artificial to natural interstellar objects? We possess no empirical data. No extraterrestrial technology has ever been definitively confirmed. The prevalence of technological civilizations within our galaxy remains unknown, as does the frequency with which they dispatch probes to other star systems. We are operating under conditions of absolute uncertainty. Loeb's methodology involved cataloging perceived anomalies and assigning approximate probabilities to the likelihood of each anomaly occurring naturally. For instance, the alignment with the ecliptic might be deemed 99.8% coincidental, with a 0.2% chance of deliberate design. The timing of perihelion during Earth's observational blackout period might be assessed as 99.5% natural, with a 0.5% chance of artificial timing. The unusual composition, the object's size, and its velocity were each subjected to similar probability assessments. These individual probabilities were then multiplied to yield an overall estimation of the likelihood that all these features manifested by chance. The fundamental flaw in this approach lies in the multiplication of uncertainties. Each individual probability assessment is a rough estimation, derived from incomplete models and scant data. When these estimations are chained together, the inherent errors compound exponentially. More critically, this method presupposes the independence of these anomalies, that the probability of one anomaly does not influence the probability of another. This is not necessarily the case. If 3I Atlas originates from a planetary system characterized by unusual chemistry, this single factor could account for both the compositional anomalies and the observed behavioral anomalies, rendering them interconnected rather than independent data points. However, setting aside the statistical methodology for a moment, let us consider the cultural ramifications. Loeb's 40% figure became a central point of contention, igniting debate not only among scientific circles, but also amongst the general public, conspiracy theorists, UFO enthusiasts, and skeptics alike. It provided a concrete number around which arguments could coalesce. Is 40% too high, too low, or even meaningful in a context of such profound uncertainty? The discourse raged across social media platforms, within YouTube comment sections, and across Reddit threads populated by thousands of posts. This extensive debate illuminated a fascinating aspect of how individuals process uncertainty. Some individuals interpreted the 40% figure as significantly high, concluding that a prominent scientist believed there was a genuine possibility of alien involvement, thus warranting serious consideration. Conversely, others perceived 40% as still below 50%, inferring that the object was more likely natural in origin and questioning the widespread alarm. The identical numerical value, filtered through divergent interpretive frameworks, led to diametrically opposed conclusions about Loeb's actual assertions. Loeb himself appeared cognizant of the attention, perhaps even relishing it. His blog posts concerning 3I Atlas became more frequent as the perihelion approached. He coined the term acid test to describe the perihelion period, marking the moment when 3I Atlas would either behave as a natural object or reveal characteristics indicative of artificial origin. He expounded extensively on the concept of an orbital maneuver, detailing how a spacecraft might leverage a close solar approach to optimize its trajectory. He also explored notions of miniature probes and motherships, as well as the potential for extraterrestrial reconnaissance missions. Within the astronomical community, his critics were far from amused. Several prominent researchers published papers and blog posts arguing that Loeb was damaging the integrity of the field by lending undue credibility to an exceedingly improbable hypothesis. They underscored the principle that extraordinary claims demand extraordinary evidence, and the evidence suggesting 3I Atlas was artificial was, at best, circumstantial. While anomalies and mysteries were certainly present, nothing at that stage necessitated the invocation of alien technology for an explanation. The criticisms were multifaceted, focusing on several key points. Firstly, that Loeb was selectively highlighting anomalies while overlooking the numerous ways in which 3I Atlas comported itself like a conventional natural comet. Secondly, that his probability assessments were subjective and lacked rigorous statistical underpinning. Thirdly, that by prominently platforming the alien hypothesis, he was inadvertently fostering conspiracy theories and disseminating misinformation. And fourthly, that he was tarnishing the reputation of SETI, Search for Extraterrestrial Intelligence, research through association. The concern was that if the public began to associate astronomers with claims of alien origins for every unusual observation, their genuine search for extraterrestrial intelligence would lose credibility. Loeb's response to these criticisms remained consistent. He contended that scientific advancement necessitates the exploration of all possibilities, even those considered unlikely. He argued that dismissing the alien hypothesis without thorough investigation constitutes dogma, not scientific inquiry. He posited that if 3I Atlas were indeed artificial and his community dismissed it without proper study due to discomfort with the idea, humanity would be forfeiting one of its most significant potential discoveries. He maintained that it was preferable to risk appearing foolish by suggesting aliens and being proven wrong than to miss the opportunity by refusing to investigate. This philosophical stance possesses undeniable merit. Science can indeed suffer from conservatism, from an inherent reluctance to embrace concepts that challenge established paradigms. Historical instances abound where significant discoveries were initially dismissed or delayed due to their perceived radical nature. Loeb positioned himself as a champion of open-minded investigation against a scientific establishment perceived as overly cautious and invested in maintaining its respectability. However, a compelling counterargument exists. Scientific progress does not stem from assigning equal weight to all potential explanations. Rather, it advances by concentrating resources on the most promising avenues of inquiry. Excessive pursuit of improbable hypotheses can divert attention and funding from research more likely to yield tangible results. Furthermore, publicly advocating for unlikely hypotheses without robust evidence risks creating a boy who cried wolf scenario. If an object is declared artificial, only to be subsequently proven natural, and this pattern repeats, the public may cease to lend credence to future suggestions of artificial origins. The tension between these opposing viewpoints played out in real time as 3I Atlas approached perihelion. Loeb continued to engage with the media, discussing the possibility of alien technology with a diverse range of figures, from Joe Rogan to mainstream news anchors. Concurrently, other astronomers persisted with their observations and analyses, largely refraining from commenting on the alien hypothesis, save to deem it improbable. Meanwhile, the public, caught between these divergent perspectives, grappled with whom to believe. The appearance on the Joe Rogan Experience proved particularly impactful. Rogan's podcast commands an audience of millions, many of whom do not regularly consume scientific content. For these individuals, Loeb's participation may have served as their initial introduction to 3I Atlas, the concept of interstellar objects, and the broader question of how we might identify alien technology. Loeb articulated his case persuasively, clearly outlining the anomalies, explaining the physics pertinent to perihelion significance, and projecting an image of thoughtful consideration rather than wild conjecture. However, he also made statements susceptible to misinterpretation. For example, when he advised actor and neuroscientist Mayim Bialik to take a vacation before October 29th, stating, "Who knows what will happen?" he was clearly employing a degree of playful hyperbole, not issuing a literal prediction of an alien invasion. Nevertheless, segments of this statement went viral, detached from their original context, and presented as a grave warning from a Harvard scientist that something momentous was imminent at perihelion. This loss of nuance transformed the statement into ammunition for both his proponents and detractors. The aftermath of 3I Atlas's perihelion has cast an interesting light on Loeb's stance. No dramatic events transpired. 3I Atlas behaved in a manner consistent with natural phenomena. No course corrections were observed, no miniature probes were deployed, and no unusual electromagnetic emissions were detected. By the very criteria Loeb himself established, the acid test yielded a negative result. The object displayed no discernible signs of artificial origin during the most critical observational window. This raises the question, was he incorrect? Loeb's blog posts following perihelion have been carefully worded. He acknowledges that 3I Atlas is most likely a natural comet, and concedes that the absence of overt artificial behavior during perihelion diminishes the probability of it being technological. However, he maintains that the possibility of subtle, undetected artificial effects cannot be entirely discounted, suggesting that the definitive test will unfold in the coming months as more data is gathered from spacecraft encounters and ground-based observations. This position is defensible but also leans towards being unfalsifiable. The hypothesis can persist indefinitely by perpetually demanding more data and asserting that definitive rejection remains premature. It transforms into a zombie idea, neither confirmed nor definitively refuted, continuing to linger in public discourse. This can be frustrating for scientists who prioritize conclusive outcomes and for the public seeking a clear answer on whether 3I Atlas is artificial or not. Beyond the specific case of 3I Atlas, the broader question pertains to Loeb's approach to science communication. Is it beneficial to publicly advance hypotheses that the majority of experts deem improbable? Does it foster productive discourse and maintain public engagement with science? Or does it undermine trust in scientific consensus and provide cover for outright pseudoscience? There is no simple answer. What is undeniable is that Loeb's involvement elevated 3I Atlas to a significantly greater level of public awareness than it would have otherwise achieved. Absent the alien hypothesis, it would have remained a topic of interest primarily for astronomy enthusiasts, confined to specialized publications and academic conferences. With Loeb championing the potential for an artificial origin, it became a mainstream news story. Millions who rarely contemplate interstellar objects suddenly became invested in the concept of perihelion. They learned about orbital maneuvers and hyperbolic trajectories, and they engaged with profound questions about the potential characteristics of alien technology and the challenges of its identification. Is such engagement valuable, even if the underlying hypothesis proves incorrect? Loeb would likely argue yes, contending that igniting public enthusiasm for astronomy and prompting consideration of fundamental questions are worthwhile endeavors, justifying the inherent risk of being mistaken about a specific object. Critics, however, would argue that excitement predicated on misunderstanding is not valuable, as it cultivates unrealistic expectations that ultimately damage the public's relationship with science when those expectations are inevitably unmet. The 40% gamble, the decision to publicly assign a substantial probability to the alien hypothesis, will undoubtedly form a part of Loeb's legacy, irrespective of future research findings concerning 3I Atlas. Should detectable artificial signatures emerge that were missed in the initial analysis, Loeb will be lauded as a brave individual who dared to consider unpopular possibilities. Conversely, if it is definitively proven to be natural, as current evidence strongly suggests, he will be remembered as someone who overstepped, allowing his desire to discover aliens to eclipse his scientific judgment. Yet, perhaps the more significant legacy resides in the discourse itself. The months of debate surrounding 3I Atlas, the arguments concerning probability, evidence, and the boundaries of reasonable speculation. These conversations compelled numerous individuals to contemplate more deeply the workings of science and the profound implications of the search for extraterrestrial intelligence. This, in itself, is a valuable outcome, even if 3I Atlas ultimately proves to be merely a comet. Deepfakes and disinformation, when scientists push back. On October 26th, physicist Brian Cox posted a message on social media that deviated from his usual content. It was not a celebration of new research or a preview of an upcoming documentary, but rather a warning. He expressed gratitude to YouTube for removing AI-generated deepfake videos that falsely depicted him endorsing conspiracy theories about 3I Atlas. These fabricated videos portrayed him identifying the object as an alien spacecraft, alleging a NASA cover-up, and suggesting that humanity should prepare for extraterrestrial contact. None of this was true, yet the content was convincing enough to sway public belief. Cox added a critical observation. It doesn't matter so much if it's nonsense about a comet, but in other areas of science and certainly politics, it's clearly important. The deepfakes were not merely vexing. They posed a genuine danger, not necessarily due to the potential for people to believe in alien comets, but because they demonstrated the alarming ease with which a credible scientist could be made to appear to utter any statement. Today, it might be about 3I Atlas. Tomorrow, it could involve climate change denial, vaccine misinformation, or any number of subjects where scientific credibility is paramount. The proliferation of deep fakes related to 3I Atlas escalated significantly in September and October, intensifying as the object's perihelion drew nearer. Multiple prominent scientists found their likenesses exploited without authorization in videos making extraordinary and unfounded claims. Michio Kaku became a frequent target. Fabricated clips purportedly showed him stating that the object was a craft, that it was drawing energy from the sun, and that insiders within NASA were in a state of panic. The disconcerting aspect was the authenticity of these clips. They utilized genuine footage of Kaku from television appearances, but the audio was either manipulated or entirely fabricated. Sophisticated AI was employed to synchronize lip movements with the altered speech. The lighting and video quality were meticulously matched to the presumed source material. For an individual scrolling through social media, these videos were virtually indistinguishable from legitimate content. They garnered millions of views, were widely shared, and influenced public perception of the 3I Atlas situation more effectively than any actual scientific communication. This was because the deepfakes were not constrained by evidence or uncertainty. They could present definitive pronouncements and offer the unambiguous answers that real scientists, grappling with ambiguous data, could not provide. The most damaging deepfake depicted a supposed emergency press conference. The video featured multiple scientists, their faces and voices synthesized, announcing that 3I Atlas had exhibited clear indications of intelligent control, that trajectory adjustments had been observed, that radio transmissions had been detected, and that governments were coordinating a unified response. None of these events occurred. The press conference was entirely fictitious. However, the video was professionally produced, incorporated realistic graphics and data visualizations, and was sufficiently convincing that fact-checking organizations felt compelled to issue specific debunking articles. The insidious nature of these deepfakes was amplified by their skillful intermingling of factual information with fabricated claims. They would commence with accurate statements, such as, 3I Atlas is an interstellar object. It is approaching perihelion, and some scientists have noted unusual properties. All true. They would then seamlessly transition to fabricated content. And that is what we are observing in this classified image, and as this leaked NASA memo reveals. This seamless transition from truth to fiction was so smooth that viewers often failed to discern where reality ended and fabrication began. YouTube eventually removed many of the most egregious videos, but not before they had been viewed millions of times and downloaded for redistribution on other platforms. The deepfakes migrated to TikTok, Twitter, and conspiracy-focused websites, where content moderation is significantly less stringent. Once content of this nature is released into the digital ether, containment becomes virtually impossible. It integrates into the information ecosystem, perpetually resurfacing and convincing new viewers. The scientists targeted by these deepfakes faced a difficult dilemma. Either ignore the fabrications and hope the public would discern their falsity, or publicly debunk them, thereby risking drawing more attention to the fakes and potentially making the debunking itself appear suspect to individuals already predisposed to believe in cover-ups. Initially, most opted for the strategy of ignoring the deepfakes. However, as the problem intensified and colleagues and friends began sending concerned inquiries about whether they had indeed made such statements, public disavowals became unavoidable. Brian Cox adopted a relatively restrained approach, simply clarifying that any video falsely attributing conspiracy endorsements regarding 3I Atlas to him was fake, expressing gratitude to the platforms that removed the content and moving on. Others adopted a more forceful stance. Several scientists published side-by-side comparisons, contrasting authentic footage with deep-faked material and highlighting telltale signs of manipulation, such as unnatural facial movements, audio that did not precisely match the supposed environmental acoustics, and inconsistent facial lighting. While these technical indicators exist, they require a discerning eye to detect and become increasingly difficult to identify as the technology advances. Kaku's team pursued a different strategy. They released a statement accompanied by timestamps demonstrating that viral footage purportedly showing Kaku discussing 3I Atlas in late October was actually from an interview conducted in February, several months prior to the object's discovery. The quoted statements were either taken out of context or entirely fabricated. However, even this detailed refutation did not reach as wide an audience as the original fabricated videos. Falsehoods often outpace veracity. The recent deluge of fabricated media brought to light a larger issue concerning the dissemination of scientific knowledge in an era dominated by synthetic content. Scientific discourse is typically characterized by carefully qualified pronouncements. Data might suggest or models might indicate that further inquiry is warranted. This inherent uncertainty is foundational to the scientific method, yet it often proves dissatisfying for the general public, who crave definitive pronouncements and clear understandings of unfolding events. Should scientific circles refrain from offering such certainty, even when the evidence doesn't fully support it, others will inevitably step in to fill that void. These fabricated media presentations offered a veneer of certainty, featuring seemingly authoritative figures making unequivocal declarations. Claims suggesting the spacecraft's authenticity and imminent governmental disclosure, while potentially unfounded, possessed a distinct clarity. This clarity, even if illusory, holds significant appeal, proving more accessible and easier to disseminate than intricate discussions involving probabilities and evidence. The challenge posed by synthetic media extended beyond video. Text-based misinformation proved equally widespread and potentially more insidious due to its ease of creation and difficulty in refutation. We encountered counterfeit scientific publications mimicking legitimate formatting and employing plausible-sounding technical jargon. Fabricated excerpts from official press briefings and non-existent social media exchanges were also circulated, all meticulously crafted to appear genuine, blending seamlessly with authentic information and lending credibility to extraordinary assertions. A particularly successful instance of textual deception involved a purported leaked internal document from the European Space Agency detailing unusual readings from the celestial object designated 3I Atlas. This purported memo contained technical specifics that resonated with non-specialists, referencing genuine ESA initiatives and personnel, and was presented with authentic letterhead and signatures. The document falsely asserted that ESA had detected electromagnetic emissions emanating from 3I Atlas, consistent with operational electronics. Despite being entirely fictitious, this document circulated for weeks before its official debunking, and even then, many continued to reference it as supporting evidence, underscoring the difficulty in dislodging deeply entrenched falsehoods. The fundamental issue with discrediting misinformation lies in its inherent asymmetry. While producing a convincing fabrication requires effort, it does not demand the rigorous validation inherent in generating authentic scientific material. Debunking necessitates elucidating the falsity of the fabrication, substantiating the refutation with evidence, and reaching the same audience exposed to the original deception. This process is inherently taxing and frequently yields limited results. Furthermore, proponents of conspiracy theories can easily insinuate that the very act of debunking is a component of a larger obfuscation. Disagreement becomes futile when individuals firmly believe all contrary evidence is manufactured. Online forums transformed into critical arenas for this informational conflict. Communities dedicated to discussions concerning 3I Atlas amassed hundreds of thousands of members in the months preceding its closest approach. These online groups comprised a heterogeneous mix of genuine astronomy enthusiasts, ardent conspiracy theorists, casual observers, and malicious actors intentionally propagating falsehoods. Administrators faced immense challenges in moderating these spaces, where genuine information, fabricated content, and speculation were intermingled within threads containing thousands of comments. Some individuals took it upon themselves to act as arbiters of truth, meticulously dissecting common misinformation with supporting sources and citations. While these endeavors proved beneficial, they also starkly illuminated the labor-intensive nature of fact-checking. For every false claim effectively refuted, 3 more emerged, creating an overwhelming challenge akin to a game of whack-a-mole played on an internet scale, where the moles often seem to be winning. Not all the misinformation encountered was intentionally malicious. A portion stemmed from genuine misunderstandings. Individuals might misinterpret scientific papers or distort graphical representations, subsequently disseminating their inaccurate interpretations as established facts. Others, through honest calculation or reasoning errors, arrived at conclusions that, while appearing plausible, were factually incorrect. This category of misinformation presents a more intricate problem, as those propagating it are not deliberately deceiving but are genuinely mistaken. Rectifying such errors necessitates education rather than mere debunking, a task that proves exceedingly difficult to achieve on a broad scale. Then there are the opportunists, individuals who perceive the event of 3I Atlas as a platform to cultivate an audience, market merchandise, and drive traffic to ad-supported websites. These individuals may not have subscribed to the conspiracy narratives they promoted. Their primary motivation was the engagement these theories generated, recognizing that sensationalism drives viewership. For instance, a video titled 3i Atlas Confirmed as Alien Mothership garners significantly more attention than one labeled Interstellar Comet Exhibits Unusual but Likely Natural Properties. The very architecture of social media platforms inherently rewards the spread of misinformation. Some of these opportunistic individuals exhibited a surprising level of sophistication. They constructed intricate networks of accounts to amplify each other's content, employed search engine optimization tactics to elevate their videos and articles in search results, and strategically embedded their misinformation within sufficient factual content to appear credible, all while aggressively monetizing their efforts and profiting from the ensuing confusion and apprehension. For them, 3i Atlas was not a scientific phenomenon to be understood, but a commodity to be exploited. The platforms themselves responded with considerable delay. YouTube eventually intervened against the most egregious fabricated media, but only after its viral dissemination. Other social media sites offered minimal intervention, allowing such content to spread with little impediment. Moderation efforts were, at best, inconsistent. While the platforms cited a balancing act between free speech considerations and the imperative to combat misinformation, critics argued that their reluctance to invest in the necessary moderation infrastructure effectively hampered their ability to address the problem. What is particularly concerning is that this episode served as a preliminary trial run. The 3i Atlas narrative represented a relatively low-stakes scenario. Convincing individuals of falsehoods about a comet carried minimal real-world repercussions. However, the methodologies developed and refined during the 3i Atlas incident are likely to be applied in higher-stakes contexts, including electoral processes, public health emergencies, and international conflicts. The infrastructure for generating and disseminating convincing falsehoods is now established, tested, and proven effective. The scientific community is actively deliberating on its response. Some researchers advocate for more assertive public engagement, directly confronting misinformation by disseminating accurate information with prominence and frequency. Others maintain that engaging with conspiracy theories lends them undue legitimacy, suggesting that scientists should instead focus on communicating with genuinely inquisitive individuals, leaving the rest to their own devices. A clear consensus on the optimal approach remains elusive. What is evident is that the traditional model of scientific communication, characterized by research publications and occasional media interviews, is no longer adequate. In an environment where fabricated media can attribute any statement to an individual, and where misinformation propagates faster than corrective information, scientists must actively participate in the information ecosystem. This necessitates a presence on social media, a comprehension of platform dynamics, and the capacity to identify and counter misinformation in real time. However, this represents a substantial demand. Scientists are trained in research methodologies, not in social media management or content creation. They are already dedicating extensive hours to their primary professional responsibilities. Expecting them to additionally police the internet for fabricated representations of themselves, to continuously debunk misinformation, and to maintain a prominent public profile, imposes an additional burden that many are neither prepared for nor possess the time to manage. The crisis surrounding the 3i Atlas fabricated media starkly exposed these inherent tensions. It demonstrated our collective unpreparedness, both as a society and as a scientific community, for the era of convincing synthetic media. The technology for creating fabricated media is now readily accessible to anyone with a competent computer and some spare time. These tools are continually improving, becoming easier to use and more difficult to detect. Simultaneously, the incentives for propagating misinformation, whether for financial gain, ideological motives, or simply to sow discord, are demonstrably stronger than the incentives for upholding truth. As 3i Atlas continues its celestial journey, the fabricated media surrounding it will likely recede. The opportunistic individuals will pivot to the next trending topic, and the conspiracy theories will lose momentum once it becomes apparent that the object is behaving naturally. However, the underlying infrastructure and established techniques will persist. Audiences have been primed, and the next instance of a mysterious celestial object An ambiguous scientific finding or any event generating public interest will likely see the reappearance of this established playbook, potentially with even greater efficacy. This encapsulates the true narrative of the fabricated media and disinformation surrounding 3I Atlas. Not merely that individuals were deceived by fake videos about a comet, but rather that we now inhabit an informational landscape where truth is rendered optional and compelling falsehoods are economically produced. Scientists engaged in a struggle with limited success, while platforms offered perfunctory moderation efforts. The misinformation continued its proliferation, driven by its inherent design to optimize for engagement, virality, and the exploitation of cognitive vulnerabilities. Our defenses against this phenomenon remain inadequate. We are in a learning phase, but the problem is evolving at a pace far exceeding the development of solutions. The purported connection between the United States government shutdown and the 3I Atlas event became a prominent conspiracy theory. On October 1, 2025, a funding lapse occurred as Congress failed to pass essential appropriation bills. This precipitated the furlough of non-essential federal personnel, the suspension of services, and consequently, NASA, like other affected agencies, ceased public operations. Agency websites ceased updates, press releases were halted, and scientists who typically engaged with the public fell silent. This occurred just 3 months prior to 3I Atlas's perihelion, a timing perceived by some as either disastrously unfortunate or, from a conspiratorial viewpoint, remarkably opportune. Precisely as public interest in 3I Atlas surged and more individuals began to focus on this interstellar visitor, NASA's capacity for effective communication regarding it was abruptly curtailed. For conspiracy theorists, this confluence of events was too compelling to dismiss. The narrative quickly emerged. A governmental shutdown coinciding with the approach of an alleged alien probe, and NASA's silence precisely when transparency was most needed, was not a matter of budgetary politics, but a deliberate cover-up. The actual circumstances, while less dramatic, were nonetheless frustratingly mundane. Government shutdowns are recurrent features of American political discourse, occurring when legislative bodies fail to reach agreements on spending bills and lack a continuing resolution. While disruptive and wasteful, these shutdowns are not strategically orchestrated to align with specific events. The October 1st shutdown resulted from political deadlock that had been developing for months, entirely unconnected to 3I Atlas or any other astronomical phenomenon. Nevertheless, timing is a critical element in conspiracy theorizing, and the perceived synchronicity of these events was sufficient to fuel weeks of speculation. NASA's shutdown protocols are designed to maintain critical operational functions. Mission control for active spacecraft, such as the International Space Station, continued to operate, and deep space missions were not abandoned. However, public communication was deemed non-essential. Personnel responsible for NASA's social media, press releases, and media coordination were furloughed. While the agency could continue its scientific endeavors, its ability to communicate them was suspended. For an object like 3I Atlas, which had gained prominence in the public consciousness through NASA's communication efforts, this silence was perceived as profound. Conspiracy theories flourished in this vacuum. Forum posts alleged that the shutdown was intentionally timed to prevent NASA from addressing questions about 3I Atlas, that the agency had uncovered information about the object it wished to conceal, and that the shutdown provided an alibi for this information blackout. It was also claimed that scientists were being pressured into silence, with the shutdown serving as a convenient justification. None of these claims held any factual basis, but the absence of official communication created a void readily filled by speculation. The conspiracy gained further traction due to the continuation of data sharing during the shutdown. The Jet Propulsion Laboratory, responsible for tracking asteroids and comets, including 3I Atlas, maintained its operations, with observations continuing and trajectory data being updated. The infrastructure for monitoring the object remained functional. However, public-facing website updates from JPL became less frequent, and the detailed daily summaries relied upon by astronomy Enthusiasts diminished in regularity. This partial communication, this sense of withheld or delayed information, reinforced the narrative of concealment. Some independent researchers continued to communicate about the object during the shutdown. Scientists affiliated with universities, funded by grants unaffected by federal appropriations, continued to observe 3I Atlas and post their findings on personal social media accounts. However, without the official endorsement of NASA, and lacking the inherent credibility of a governmental agency statement, their communications were more easily dismissed or reinterpreted. A NASA press release affirming the comet's natural behavior carries significant weight, whereas the pronouncements of an individual astronomer can be disregarded or countered by conspiracy theorists who might accuse the scientist of being silenced or misled. The shutdown persisted into mid-October, encompassing nearly 2 weeks of informational ambiguity at a critical juncture of 3I Atlas's approach. When NASA services resumed, a substantial backlog of inquiries and information requests existed. However, the damage to public perception had already been inflicted. The conspiracy theories had taken root, establishing and reinforcing the narrative of NASA withholding information for 2 weeks without effective counter-argument. A specific controversy arose during the shutdown concerning images purportedly captured by the high-resolution imaging science experiment, HiRISE, camera aboard the Mars Reconnaissance Orbiter, MRO. 3I Atlas passed relatively near Mars on October 3rd, and the HiRISE camera was reportedly tasked with observing it. One individual claimed during a televised appearance that these images existed but were never released, stating that a request to the principal investigator had gone unanswered. With NASA in shutdown, an effective response to these claims was impossible, and the absence of a reply was interpreted as confirmation that the images existed and depicted something NASA wished to keep from the public. The reality was more complex. The HiRISE camera is designed to photograph the Martian surface from a few hundred kilometers above the ground, excelling at resolving minute surface features. However, even at its closest approach to Mars, 3I Atlas remained over 29 million kilometers away. Capturing an image of such a distant object with an instrument intended for close-range, high-resolution imaging is exceedingly difficult. The comet would have appeared as little more than a faint smudge, rather than the detailed imagery envisioned by conspiracy theorists. The ExoMars Trace Gas Orbiter did succeed in capturing images of 3I Atlas during its Martian flyby. These images revealed precisely what was anticipated: a slightly fuzzy white dot against a backdrop of stars. The comet's coma was barely discernible, and its nucleus remained invisible. These were not dramatic, detailed images that would reveal artificial structures or anomalous features. Rather, they were marginal observations confirming the object's position and approximate brightness, consistent with what professional astronomers would expect under those geometric conditions. The ExoMars images were not released immediately, partly due to the shutdown and partly because image processing requires time. By the time they were finally disseminated weeks after the Mars encounter, many had already concluded that NASA was deliberately concealing information. The existing images were not sufficiently striking to alter these convictions, and the detailed high-resolution photographs depicting alien structures that conspiracy theorists desired simply never existed. The shutdown conspiracy also intersected with the International Asteroid Warning Network's IAWN decision to add 3I Atlas to its observation list. This action occurred on October 1st, the same day as the shutdown. IAWN's list includes objects requiring particular tracking attention, typically due to potential hazards to Earth. While 3I Atlas posed no threat and was not on a collision course, it was added by IAWN due to the unpredictable nature of interstellar objects and as a valuable training exercise for planetary defense protocols. The organization sought to practice coordinating observations and data dissemination for an object that might present unexpected characteristics. The timing of this inclusion coinciding with the shutdown was purely coincidental, as IAWN operates independently of NASA's budgetary politics. However, to conspiracy theorists, the pattern was undeniable. First, 3I Atlas was added to a list warranting special attention, and then, hours later, the government shut down and NASA ceased communication. This was interpreted as clear evidence of preparation for something significant and an indication that the object was more dangerous than officially acknowledged. The fact that IAWN explicitly stated the object posed no threat was disregarded. Actions, in this context, were perceived as speaking louder than words, with the inclusion on the list carrying significant weight for those predisposed to perceive meaning in coincidence. The psychological phenomenon at play here is termed epiphenomenon, representing the tendency to discern meaningful connections between unrelated occurrences. Humans are innately pattern-seeking creatures, having evolved pattern recognition abilities that conferred survival advantages, such as anticipating weather changes or recognizing predator presence. However, the same cognitive mechanisms that identify genuine patterns are also susceptible to fabricating spurious ones. In a complex world where numerous events unfold concurrently, false patterns are readily discoverable if one actively seeks them. The correlation between the 3I Atlas event and the government shutdown serves as a prime illustration. Two significant occurrences, the federal funding lapse and the comet's approach, transpired simultaneously. If one is intent on establishing a connection, it can be constructed. The government possesses prior knowledge regarding the comet, and the shutdown is a tactic to control information flow, signifying preparation for undisclosed events. The narrative essentially writes itself, with each new piece of information interpreted to reinforce the established pattern. Information contradicting the conspiracy is reframed as evidence of a cover-up, while supporting information is accepted as confirmation. This creates a closed belief system that is exceedingly difficult to penetrate from external perspectives. What is particularly noteworthy is the international scope adopted by the conspiracy. The shutdown exclusively impacted United States government entities. The European Space Agency continued its operations without interruption, as did the Japan Aerospace Exploration Agency, the Russian space program, and the Chinese space program. A coordinated cover-up regarding 3I Atlas would necessitate an unprecedented level of international collaboration, involving space agencies that often struggle to agree on mission parameters, to seamlessly orchestrate an information blackout. Such a scenario is highly implausible. However, conspiracy theories are not constrained by plausibility. Another intriguing element is the rapid evolution of the conspiracy from NASA knows something to NASA is not the sole entity aware of this. The theory expanded to encompass other space agencies, and even amateur astronomers who challenged the conspiratorial narrative were accused of being informants or intimidated into silence. This represents a common trajectory for conspiracy theories. They metastasize, incorporating new elements to explain away contradictory evidence. The more elaborate the conspiracy becomes, the more unfalsifiable it proves. It becomes impossible to disprove a theory when every piece of contrary evidence is reinterpreted as an integral part of the conspiracy itself. Upon recommencing operations in the middle of October, NASA found itself in an untenable predicament. The agency faced a critical decision: directly confront the swirling conspiracy theories, a move that would amplify their reach and potentially cast their defensiveness in a dubious light, or dismiss them in hopes of their natural dissipation, thereby allowing the narratives to persist unchallenged. They opted for an intermediate strategy. This involved issuing precise declarations concerning the orbital path and characteristics of 3I Atlas, emphatically asserting its lack of any discernible threat, yet refraining from explicitly addressing allegations of clandestine activities or withheld data. This measured response failed to appease anyone. Those who subscribed to the conspiracy mindset perceived the meticulously crafted statements as precisely what one would anticipate from an entity determined to conceal the truth. Conversely, individuals advocating for a forceful debunking of these theories were left underwhelmed by the restrained reaction. And those merely seeking clarity on the situation surrounding 3I Atlas found themselves sifting through a mire of speculative claims to unearth factual information. The governmental shutdown, however, had one undeniable outcome. It propelled 3I Atlas into a more prominent spotlight than it would have otherwise commanded. The void of information during those 2 weeks in October created a fertile ground for alternative narratives to take root and proliferate. When NASA's operations were restored, they were not merely contending with ordinary ambient discourse, but with 2 weeks' worth of accumulated conspiratorial thinking. While the shutdown did not originate the conspiracies, it undeniably provided an ideal environment for their growth. And here lies the uncomfortable truth. Certain criticisms leveled against the shutdown were entirely valid. Government shutdowns are inherently chaotic. They represent a squandering of resources, impede crucial work, and erode public faith in governmental bodies. It is unreasonable for NASA to be forced to suspend public engagement due to Congress's inability to pass a budget. The paradox of critical scientific endeavors continuing while public accountability is suspended presents a significant issue. One can critically examine the systemic failures that led to the shutdown without subscribing to beliefs in extraterrestrial cover-ups. However, legitimate critique and conspiratorial thinking often occupy the same intellectual space, making distinctions difficult. An individual expressing reasonable concerns about transparency during the shutdown could easily be associated with those alleging NASA was concealing alien spacecraft, a connection that would hinder the reception of legitimate criticisms. The pervasive conspiracy theories tainted the discourse, making any questioning of NASA's handling of the situation appear suspect. The shutdown concluded, NASA resumed its duties, and data transmission recommenced. Ultimately, the shutdown exerted minimal influence on the core scientific understanding of 3I Atlas. Observations were consistently maintained, and international collaboration helped bridge any informational gaps. The comet's trajectory remained unequivocal. However, the conspiracy that blossomed during the shutdown, the pervasive notion that something was being concealed, lingered long after funding was reinstated and furloughed employees returned to their posts. This is because once a conspiracy theory gains traction and individuals invest their belief in it, contradictory evidence often fails to dismantle it. Instead, the theory adapts to incorporate new information. Consequently, the October shutdown, despite its ostensibly mundane political origins, became an indelible element of the 3 Atlas saga. The Chinese silence, whether a deliberate cover-up or merely a consequence of processing delays, became a focal point. On October 3rd, as 3 Atlas made its closest approach to Mars, numerous spacecraft were strategically positioned to document the event. The European Space Agency's ExoMars Trace Gas Orbiter captured imagery, while Mars Express directed its instruments towards the passing celestial body. It was even reported that NASA's Martian surface rovers were tasked with imaging the visitor. Yet, a significant absence dominated online discourse for weeks following the event: China's Tianwen-1 mission. This mission, which had previously released over 14,000 images from Martian orbit since its arrival, produced precisely 0 photographs of 3I Atlas. This silence was strikingly conspicuous. Tianwen-1 possesses sophisticated imaging capabilities, orbits Mars, and China's space program has consistently demonstrated an eagerness to publicize its accomplishments through the regular dissemination of impressive imagery and scientific data. Therefore, when one of the most intriguing interstellar visitors in recent memory passed within 29 million kilometers of Mars, and China's orbiter apparently failed to capture or subsequently release any images, observers took notice, igniting a wave of speculation. Online forums were abuzz with theories. The most prevalent narrative suggested that China had indeed captured images of 3I Atlas, and these images revealed something of considerable significance, something that contradicted the official explanation of a natural comet, hinting instead at artificial structures or unusual formations. To avoid an international incident or the premature disclosure of sensitive information, China, according to this theory, simply remained silent. The lack of visual evidence was posited as more impactful than any potential photograph. A discussion thread on an astronomy forum titled "The Chinese Silence on 3I Atlas is More Concerning Than NASA's" garnered thousands of responses within days. The central premise was straightforward. If the object were an ordinary comet, China would have undoubtedly released images promptly to outshine NASA and the ESA, showcase Tianwen-1's capabilities, and secure a propaganda victory in the unspoken yet palpable space race. The absence of images, therefore, implied they were too sensitive for public release. What could be sensitive about a comet? Only one possibility. It wasn't a comet at all. The reality, as is often the case with conspiracy theories, was far more prosaic. Tianwen-1's imaging systems are primarily calibrated for photographing Mars, not distant comets. The spacecraft's orbital trajectory and instrument targeting are meticulously planned months in advance, guided by scientific priorities unrelated to interstellar visitors. Obtaining a clear image of 3I Atlas would necessitate reorienting instruments, adjusting the orbital plan, and potentially delaying other scheduled observations. Furthermore, this entire endeavor assumes that the comet would even be detectable within Tianwen-1's field of view at the opportune moment, with appropriate exposure settings. However, setting aside the technical challenges, let us examine the geopolitical dimension, which rendered the Chinese silence conspiracy so compelling. Space exploration has invariably possessed a geopolitical undercurrent. The initial space race between the United States and the Soviet Union was as much a demonstration of technological prowess as it was a pursuit of scientific discovery. Today's space programs, while outwardly more collaborative, still harbor underlying nationalistic sentiments. China's rapid advancements in space technology are celebrated domestically and viewed with apprehension by Western nations. Within this context, the notion that China might strategically withhold data concerning 3I Atlas is not entirely without foundation. Should Chinese scientists have indeed observed something genuinely anomalous, something defying natural explanations, there could be compelling reasons to classify such information, not as evidence of extraterrestrial life, but because any ambiguous findings regarding an interstellar object could be politically exploited. Remaining silent would be a more prudent course than releasing partial data that could be misinterpreted. Nevertheless, this line of reasoning presupposes the existence of images in the first place, an assumption that lacks substantial support. Observations from the ExoMars mission, which were eventually released, depicted 3I Atlas as a faint, indistinct blur. Even with instruments specifically designed for such purposes, photographing the object proved challenging. Tianwen-1's cameras, aimed at a comet located 3 astronomical units away while in Mars orbit, would face even greater difficulties. The signal-to-noise ratio would be exceedingly poor, and the comet might be imperceptible against the background noise. Moreover, China's space program operates on different temporal frameworks than Western agencies. Data processing and release schedules are characterized by less transparency and predictability. Tianwen-1 has, on occasion, taken months to release images from routine Martian observations. The absence of 3I Atlas images within days or weeks of the encounter does not necessarily indicate malfeasance. It could simply mean the images are awaiting processing, are undergoing analysis prior to release, or were not deemed scientifically significant enough to warrant immediate prioritization. Conspiracy theories, however, thrive not on evidence, but on its absence. The lack of Chinese images of 3I Atlas is not definitive proof of a cover-up. Yet, within the logic of conspiratorial thinking, it aligns perfectly with the notion of something being concealed. In the absence of a clear official explanation for the non-release of images, speculation inevitably filled the void. The narrative of Chinese silence also tapped into broader anxieties regarding information control and transparency in space exploration. While China's space program has become increasingly open, it remains less transparent than NASA or the ESA. Launch schedules are sometimes announced with minimal advance notice, and technical details are often scarce. Scientific findings are published, but with less elaboration and fanfare compared to comparable Western missions. This inherent opacity, a blend of cultural norms, institutional practices, and deliberate choice, fosters an environment conducive to speculation. Some observers pointed out that if China had indeed captured remarkable imagery of Three-Eye Atlas, they would be more inclined to publicize it than to conceal it. The discovery of an interstellar object exhibiting signs of artificial origin would constitute the scientific revelation of the millennium. The nation making such an announcement would undoubtedly dominate global headlines. China would stand to gain immensely and lose nothing from such a revelation, provided the evidence was irrefutable. The fact that no announcement was made suggests they had nothing momentous to report, rather than actively concealing something significant. However, this counterargument found little traction among conspiracy theorists, as it relies on the assumption of rational behavior by governmental institutions. Conspiracy theories are predicated on the notion that institutions do not act rationally, and that hidden agendas and secret knowledge dictate decisions that appear illogical from an external perspective. If one begins with the premise that governments routinely suppress critical information, then the absence of Chinese images becomes evidence of concealment rather than evidence of a lack thereof. The comparison with NASA was particularly stark in these discussions. When NASA experienced a government shutdown and ceased communication, it was deemed suspicious. Similarly, when China operated normally but withheld image releases, that too was viewed with suspicion. Conspiratorial thinking had reached a point where any action or inaction by any space agency could be construed as evidence of a cover-up. Transparency was viewed with suspicion, prompting questions about what agencies were attempting to make the public believe by being so open. Conversely, opacity was equally suspect, leading to inquiries about what was being hidden. This created a no-win scenario for the agencies striving to communicate scientific findings. Interestingly, some Chinese space enthusiasts and amateur astronomers actively challenged the conspiracy narratives on international forums. They highlighted that Tianwen-1's observation schedule is publicly available, that there is no definitive evidence the spacecraft was even oriented towards Three-Eye Atlas during the Mars encounter, and that expecting real-time image releases is unrealistic. These voices provided valuable context, but were frequently disregarded or dismissed as propaganda by conspiracy theorists, who presumed that anyone defending China's space program must be acting under governmental directives. This dynamic exposes a troubling aspect of international scientific collaboration amidst geopolitical tensions. Scientists worldwide, including those in China, generally share common interests: understanding the universe, advancing knowledge, and jointly tackling complex challenges. However, the institutional frameworks within which they operate and the nationalist narratives surrounding space exploration can impede this collaboration. When every data release or its absence is interpreted through a geopolitical lens, pure scientific communication becomes exceedingly difficult. These narratives were further intertwined with claims of leaked information. Several social media accounts purported to have insider sources within the China National Space Administration, who allegedly confirmed the existence of images depicting anomalies. These claims, however, remained unsubstantiated. No leaked images materialized, nor did any whistleblowers with verifiable credentials emerge. Nevertheless, these rumors circulated widely, gaining a veneer of credibility through sheer repetition rather than factual evidence. One particularly persistent rumor involved an alleged internal memorandum from CNSA to Chinese astronomers, purportedly instructing them to refrain from discussing Three-Eye Atlas publicly. This memorandum was never produced, yet its supposed existence was cited in numerous forum posts as proof of a coordinated effort to maintain silence. This phenomenon is a common characteristic of conspiracy theories. Non-existent evidence is treated as evidence of successful concealment, which, within the framework of conspiratorial logic, validates the conspiracy's existence and efficacy. The reality is that Chinese Mars missions will likely release images eventually, assuming any were indeed captured. China's space program has progressively increased its transparency and data-sharing initiatives. Tianwen-1 data is published in scientific journals, and images are disseminated through official channels, albeit with an unpredictable timeline. For an object like 3I Atlas, which captured public attention at a specific juncture, a delayed data release misses the window of relevance. By the time Chinese images are made public, if they ever are, the public discourse will have moved on. This, perhaps, is an integral part of the story. The Chinese silence may not have stemmed from strategic maneuvering or conspiratorial intent, but rather from bureaucratic inertia, the consequence of an institution that operates at a slower pace and does not prioritize rapid public communication. However, within the hyper-accelerated information ecosystem of social media, where news cycles span mere hours and public interest is ephemeral, slow communication is virtually indistinguishable from no communication. This absence of timely information invariably creates space for speculation to flourish. The geopolitical dimension of the 3Y narrative is frequently overshadowed by the more sensational alien conspiracy angle, yet it arguably holds greater significance. We are entering an era of multipolar space exploration, wherein the United States no longer holds a solitary dominance. China is successfully landing rovers on Mars and exploring the far side of the Moon. India is dispatching probes to asteroids, and the European Space Agency is planning ambitious missions. Concurrently, private enterprises are emerging as significant players. This decentralized landscape, while scientifically exhilarating, presents a chaotic communication environment. Different agencies operate with distinct priorities, temporal frameworks, and varying degrees of transparency. When an event like the passage of 3I Atlas captures global attention, coordinating communication across all these entities becomes an insurmountable challenge. Some will disseminate data promptly, others will proceed at a more deliberate pace. Some will engage with speculative discourse, while others will remain silent. Within this inherent inconsistency, conspiracy theories find fertile ground. If all parties possessed identical information and communicated it with clarity, there would be little room for alternative narratives. However, such a level of coordination is unattainable and likely will remain so indefinitely. The Chinese silence will likely endure as one of the unresolved enigmas in the 3II saga. Not due to any deliberate concealment, but because the absence of anticipated communication can never be definitively explained. One cannot definitively prove why something failed to occur, nor can one provide evidence for missing evidence. It is within this chasm between expectation and reality, between what the public anticipated China would release and what was actually presented, that conspiracy theories have firmly established their foundation. Their basis lies not in what was observed, but in what was not. Their sustenance is derived not from data, but from its absence. And in the realm of conspiratorial thinking, absence can frequently serve as the most compelling form of evidence.